on this.
Mic on nahi hai, sir.
A very good morning to all of you present here, and welcome on this third day of international workshop on hydrobiology. It is a privilege for me to introduce our esteemed speaker, Dr. Nandini Sharma, ma'am. Greetings, ma'am.
Good morning.
Here is a short introduction for ma'am. She obtained her academics, including masters and PhD at University of Delhi, where she also pursued her postdoctoral for 2 years. She did a training course in lake management at University of Ghent, Belgium, and started working at Faculty of Higher Studies Iztacala at University of Mexico. Her topic of interest are aquatic ecology, mainly cyanobacteria, zooplankton, and fish. She has published more than 275 research articles in reputed national and international journals, including Nature. She has imparted 40 courses in Mexico and India on zooplankton culture, aquaculture, ecotoxicology, and the art of scientific writing. She has also guided thesis.
Recording in progress.
She has also guided thesis of more than 60 students and scholars, delivered more than 130 lectures at national and international conferences. She is also an editorial board. She's also on the editorial board of international journals. In 2012, she was awarded with Scientific Merit Award from FES Iztacala. Today, she will be delivering a lecture on the topic Tips for Writing a Scientific Manuscript. Welcome, ma'am.
Thank you very much. Thank you very much for your very kind introduction. So may I start then? I'll try to share my screen. I hope it won't give me much trouble. Oh, it's not turned on. I have to request you to allow me to share the screen.
Yeah, Nandini, now we can start. It is allowed.
Okay. I have to open this. Oh, it's not allowing.
No, again you check in. Again you get into the Zoom. You cancel and again share the screen.
I have to cancel the Zoom.
No, share the screen.
Share the screen.
Cancel and again get in. Because
I tried to open the page.
it showed actually. I don't know why. Yeah, exactly this one.
Can you see the screen?
Yeah. Now you can also
Yes,
put on mode of presentation. Yeah.
Yeah.
Yes.
And is it moving? The slides
Yes.
are.
Yes.
Yes,
Okay.
it is moving.
Okay. Thank you. Thank you very much. Thank you very much. So this is the topic that I would like to talk to you about today, about writing manuscripts. So I'll give you some tips about how we do it, and perhaps it might help some of you to write prolifically and publish a lot. So why should we publish? The first point is that science grows by knowledge, which is generated globally. So everybody does not have to repeat everything. So this information that you generate in your laboratory, nobody else can do it, right? And this information has to be shared because we don't know what rotifer is growing in the ponds of Chhattisgarh. So you will study it and you will publish it, and then we will know which rotifer species are found here. So this is very, very important. The fact that we should share this knowledge, and this is not new to us. This has been there from the time that Vedavyas wrote the Vedas. So from that time onwards, we have to share our information. You can also share your information in conversations, in conferences, in seminars, but the one that is most standard and most utilized around the world are publications in peer-reviewed journals. We all know this adage, publish or perish. I would not like to scare the students, but the fact is that publishing should become a habit for you. Once it becomes a habit, you will never have to worry about anything else in your academic career. Now, we do research for curiosity. That is right. You should work on the field that is of interest to you, but eventually you must publish this information. And did it change the slide?
Yes, ma'am.
Okay, thank you. This table is very interesting for all of you here in India for two reasons. Number one, I would like to highlight the fact that only in 2018 or 2020, China could overtake the United States in the number of publications. So today, China is the country which publishes the most number of scientific articles, and it is followed by the United States. However, in terms of citation, it is, I don't know how this red line came. In terms of citations, United States is still the leader. The second point of great interest is the position of India. India has risen to the 4th position in the world, and this is extremely great achievement for our country. And you must be very, very proud of yourselves. You must try to contribute to this also, because India is now a leader in many fields and in scientific articles too. And you have access to many, many journals. I was told that more than 13,000 journals are being made available to all Indians. So please study the literature. This is not a very interesting right now. I'll just skip these slides. And okay, here, why this line came with us? Just 1 minute. There seems to be a red line that is appearing here, but I don't know from where it appeared. But anyway, I'll continue. You just ignore the red line. Okay. So the point is that why should we publish? It is very important for the reputation of your university, for the reputation of your country, for your own reputation, for that of your professors. So publication is very, very important. It is very important to prepare our students to publish effectively. Citations are the number of times people use your data, and that is the final credit for you. It's not enough just to publish. It is important to publish good articles which are cited by other people. The second point is that you must study two things. One is the impact factor of the journal where you want to publish, and the second is the quartile. So the quartile is that you have 4 different quartiles in different areas of research. Formerly, you could have only the impact factor. So what happens is now, if people are publishing, for instance, in medicine or in molecular biology, many researchers are publishing all over the world. So those journals will have a very high impact factor. And aquatic ecology journals will have a low impact factor because few people are publishing. So now they develop the system of quartile so that there is a even level playing field. So now it is possible that you have an impact factor of 15 but in molecular biology, but the quartile may be 2 or 3. So in aquatic ecology, if you have an impact factor of 8, it will be a quartile 1. So you must pay attention to these details before choosing the journal where you want to publish. You also must be realistic in your aspirations. Do not try to publish your very first article in Nature until and unless you feel that it is something so novel, so useful. Then, of course, you must try. Now, before we decide to publish, we must think. we must sit and think, why do I want to submit my results? You want to submit your results because they are valuable. You want to submit your results just because you need an article for getting your degree. So you must think carefully. Journals will be very selective these days. There is a very, very high rejection rate in journals, close to 70% in many journals, 80%, 90% in others. So be careful. Send your work when you think that it is perfect. Be realistic, choosing the journal, and explain to the editor. You have to explain to the editor in 5 sentences why your article deserves to be published. So these things are very important before you start the publication process. Okay, now consider this chart. It also indicates how much you read. So if you want to write well, you must read a lot. You can read anything. You can read the newspaper, you can read articles, you can read storybooks, you can read great authors. But the habit of reading is very important. And here also, it was an excellent piece of data that I just saw this morning, that after United States, the country that reads the most is India. And that is the latest data. So it's very nice, and you should feel very proud that you belong to a country where everybody reads so much. Please develop the habit of reading. Please focus on the style of writing of any author that you read. Okay, so now the first journals, they appeared in 1665 in France, in Europe, and one of the very old journals, the Philosophical Transactions of the Royal Society of London, still exists. It's more than 100 years old, 150 years old. It's a very old and very reputed journal. There are more than 40,000 scientific journals these days. And one of them, most of them could be either open access or non-open access journals. So you will have journals which could be you free to publish, or you have to pay. So these things we will discuss now in the next slides. Just give me one moment, please. I don't know what to do. Can you see the presentation complete? Just one moment. I'll just ask you to give me a moment. Oh, where is my-
Ma'am, we are seeing it, but it is not in the slideshow mode.
Yes, yes. I'll just.
Okay, okay.
Can you now see?
Yes, ma'am.
Okay. Okay. So I'm sorry for that interruption. So now let's see what kind of, I was talking, let me go back. Yeah. So now most journals follow this style of writing the introduction, methods, results, and discussion. But some journals follow the style of writing first the introduction, then the results, then the discussion, and then the methods, because they are more interested. The scientists who read these journals are probably aware of most of the methods. They are more interested in your results. So you have to be very careful and follow what is known as instructions to authors. Instructions to authors are given in all journals, and you must follow them completely without fail so that your article is acceptable and the editor is not perturbed by receiving your paper. Because if he takes a decision or she takes a decision, at that point, your article is out of the system. So be very careful how you prepare your work. So now let's see what are the different types of articles that are published. First of all, we have original piece of data and analysis, absolutely original work. For instance, if a young student was studying the rotifer diversity in a pond in Chhattisgarh, that is totally original. Nobody else has studied it. So that is the kind of work that most people publish. Then you have a review paper. In a review paper, you have to analyze, evaluate, synthesize the previously published information. You should be very careful. Young people confuse between a review and the literature that they review. So when you compile the literature, that is a compilation. That is not an analysis of the literature. If you analyze the literature and prepare new graphs, show some new ideas, and present the data in, for instance, 50 articles in a different format, that is a review. But just compiling data and saying he did this, they did that, we did this, that is not a review. So you should be very careful in distinguishing this. You must be able to generate new ideas, new paradigms, new theories. Then it is a useful review. So normally reviews are left for the senior scientists to do. Then you have conference reports and extended abstracts. You should be careful what you publish here, because publication is a very, they focus a lot on ethics. So what the problem is that once you publish your data in a conference report or an extended abstract, that data should not be published again in a paper. You can only cite that data. So the best thing to do is that when you have to do a conference report or an extended abstract, publish only a small quantity of your data. Don't present all of it. And keep the solid work for the article. This is my suggestion to all of you. Now, how do you begin? You first find your interest. You read a lot. You pay attention to the style of the author while reading. So this is very important so that you will develop a good style of expression, revise the literature thoroughly. Nowadays, since we are already 25 years into this century, please do not cite too many works from 1970s and 1980s. Look at the data, study more, and try to cite research which is more recent from 2000 onwards. You can keep 10% of the citations for 1980s, 1990s. Then you should be cataloging your references carefully, especially young people. This is the time when you should use programs such as a reference manager or EndNote, in which you can put all your references in the computer with a brief explanation of each article. This is very useful when you have to look for adequate citations for your discussion, for your introduction. Discuss whatever problem you have with your peers and supervisors. Generate a very good question and then very good data. Now you are ready to prepare your article. In our times, we did not have access to computers like young people have today. And we had to go through current contents in the library and spend hours and hours to send the messages to the scientists and then wait for days and months for them to send an article to us. So times have changed and these are for the better. Please utilize all the facilities that you have now. Now, what makes an article acceptable? The first point is that it should fit the scope of the journal. Your data may be excellent, but if you are publishing on rotifers and send it to an article, send it to a journal that talks about maybe conservation, it won't fit. So you should be careful. You should be careful how you are presenting your research, and it should fit the scope of the journal. The second point is that the content, the data must be very sound and very good. The quality of the data should be excellent, and most important, the presentation. Like Professor Dumont, who was the editor-in-chief of Hydrobiologia for more than 25 years, he said very clearly, he said, well-presented mediocre data can be more easily published than poorly presented excellent data. So do not lose your data and do not lose the opportunity of publishing just because of poor presentation. Instructions to authors, I already told you about it. It is a section which is there in all journals. You must follow it very carefully. You must read one article published in that journal. You must try to cite articles of that journal in your text so that the editor is interested in publishing your research. So you look very carefully at all the details. And now you see what are the this part of protocol and thesis, please ignore, but look at only the articles. So these are the different sections that each scientist has to prepare before he tries to send his article. You need to have title, author, your address, the keywords, abstract, introduction, methods, your results presented as graphs, figures, and also an explanation, tables, then you have discussion, acknowledgements, references, and the figure legends. Okay. How do I do it? I normally start by writing the methods, by focusing on the results, so that now I have a clear picture of what I did, what I have. Now, based upon that, I start reading a lot because I have already read about the subject, but I read more and I find a good justification. After I do all this, I try to write the, 3 or 4 different titles, the author's address, keywords, these are simple. And then I start writing the introduction. Now I also have my results ready, so I can write a discussion also. Then the abstract is supposed to be written in the end. And do not forget to acknowledge all the funding agencies and the people who have helped you academically for preparing the manuscript. Now look at this point. Who deserves to be an author? This is a very important subject. It is not something that you should take lightly, because nowadays all journals ask that the author's contribution to the work be explained clearly. So the person who generates the idea gets the first place. Then you have people who are helping you with the experimental design, generating the data, analysis, writing, taking responsibility. All of these are important for being an author in the work. Simply contributing by buying some chemicals or by buying a microscope is not enough. You need to do the work associated with the manuscript. And then it's good to be associated with well-known authors because it'll ease the process of publication for you. And be careful that anonymous ghost authors are not allowed. So authors are all those who contribute intellectually to the design of the experiment, to the work. So if you have too many authors in a small piece of work, it will dilute the effort of the real workers and maybe the editor does not like it. So depending upon that, if you have, for instance, 10 or 15 graphs, yes, you have a lot of data, so you can probably have 6 to 7 authors. But if you have just 3 graphs and you want to put 8 authors there, then the editor asks a question that why? Now, the first author is the primary author, even if he or she is a student. The corresponding author is the one who takes charge of writing the manuscript, communicating it to the journal, and revising it, checking the proofs, etc. So it is, these two positions are very important, the first author and the corresponding author. Some authors, like you see this book and you know this man, but you do not cite the year of his publication. It is well understood what you are referring to. So there are very few people in the literature who have this, respect and priority. This is another very interesting story about Lowry et al. Lowry developed this technique for determining proteins, and he never published it. He shared it with everybody, but he never published the process, the method. And then finally, he shared it with his friends. The friends said that it is excellent. Now all of them decided that they must publish it. They published it, and look at the number of citations, more than 350,000. It is only increasing day by day. So it's it's a classic paper, and it shows the importance of publishing. You may do some excellent work, but if you do not publish it, you will not receive the credit for it. Okay, look at the title page. See how much time I have. Okay. So if you look at the title page now, you should put all the people, the title of the work. First of all, you put the authors, the addresses, and the title of your study. The keywords, sometimes they like it, sometimes they don't. The instructions to authors will explain that to you. And you come to the title. A good title uses very few words to explain all the contents of the paper. The most important concepts that you have studied should be there in a good title. And a very nice tip was shared with us by Dr. Ramesh Gulati, who was also editor-in-chief of Aquatic Ecology. He said, write 4 or 5 different titles and just leave it. Do not look at them for a few days. Now, after 4 or 5 days or a week, look at all the titles and choose the most adequate one, or try to modify based upon all the 5 different titles. So this should be done normally only after the manuscript is written. Do not write full sentences in the title. It's just a title, so it does not need to follow the format of a complete sentence. Be careful with the words that you use. Avoid any waste words in the title. Okay, this we don't have to look at. Now you look at the authorship. I already told you that you should be very careful. Who are the authors? The first author, the corresponding author, very important. And then the address. It is extremely important to put the address of your institution and the institution where you have done the work. If it is in your own institution, no problem. But if it is in another institution, do not forget to put your own institution also. Because if not, your institution gets no credit for your effort. So be careful with these details. Now look at this, the activities associated with the research manuscript and the number of points. Many laboratories follow such charts, and they clearly put who has done what. If you conceptualize the work and give the idea, you get immediately 50 points. If you write the first draft of the manuscript, you get another 50 points. So these are the 2 most important things. If you look at this whole list, all the rest is after this. But you must be able to find yourself somewhere in this activity category. If not, you do not deserve to be an author. Abstracts, some tips to write a good abstract. First of all, you should not exceed the limit which is set by the journal. You should write the aim of your investigation, the methods that you use, the results in brief, and the important conclusions in the abstract. It should be prepared after the manuscript is done, And it is very important that you do the abstract exactly in the number of words. We like to put some quantitative data in the results because many people do not have access to all the articles. So they will cite your work if you have data in it. If you don't have data, your work will probably not be cited. So think about it and try to put a little bit of results also in your abstract. Now, your introduction, some tips, they should be general to specific, general concepts and then specific concepts. Understand that you are writing for a group of people who are well aware of what you are doing. So you do not have to explain what is a rotifer to these people. You have to explain about the diversity of rotifers in India to this group of people. So think carefully about your audience, what you are writing. Review the literature very carefully, put emphasis on the ideas, not the person who does the research, and give a clear reason for doing the study. And these three concepts, the justification, the aims, and the hypothesis, normally is presented in the last paragraph of the introduction. So a few more general suggestions based on my personal experience. First, write general to specific. Who are the readers of your text? Be careful about that. Try to put it in 5 or 6 paragraphs. 1 to 2 concepts per paragraph, no more than that. Write in short sentences which are easy to understand. Continuity of thought is very important. So the previous paragraph should automatically lead to the next one. Try to be continuous. This is an important point. And then your references should come after the ideas, not at the end of the paragraph. Be careful about cross citations. Do not do too many cross citations. That weakens the work. Do 10 to 15 lines per paragraph. And the more you read, the better will be your text. Another important point is that try to keep it within about 2.5 to 3 pages, your introduction in double space. So that would be about 700 to 800 words maximum. Be careful, that's what we said, that avoid any fancy language, big words. You don't need to show your, your literary skills here. You just need to write very clear, short sentences. If you write in a simple manner, it will be more acceptable and more appreciated. Do use standard abbreviations. If you're using personal abbreviations for anything, please explain very clearly and write carefully. Try to minimize the words because publishing each word is expensive. So if you write in the month of January, January cannot be anything else but a month. So simply say January. So now you have avoided 4 words. We normally suggest to our students to develop their justification for their research by revising the literature, studying 200 to 300 abstracts, and seeing what areas have been well studied and which ones need more study, so that now you have a very clear and a quantitative idea of why you are conducting your research. So this I already told you that the last paragraph of the introduction is the justification, the aims, and the hypothesis. All these 3 points should be present in the last paragraph of the introduction. Write materials and methods. In Mexico, we explain that do not use the word methodology because they tend to use that. Do not use the word methodology. It means something else altogether. Use complete scientific names and that of the authors, as Dr. Sarma explained to you yesterday with the with rotifers, the names of the rotifers and the descriptors of each species. Then you write in the past tense and write in a logical order. It is possible that you had a culture of Brachyonus caliciflorus in your lab and you did some studies on fish feeding with them. But of course, when you write the article, you should clearly start with the rotifers were cultured from a sample collected in so-and-so lake and in this manner, etc., etc. So it is not exactly in the order in which you do the work, but in the order in which makes most sense. So write carefully about that also. Be careful about your style of writing. Novel techniques, if you have developed a new technique like Lowry et al., it is extremely well cited. So think about sharing these ideas also with the scientific community. Now we come to the results. So we finished the methods. This is absolutely the heart of your paper. It is the most important section. And if you have good, solid results, it is very likely that your manuscript will be accepted. Now, study these results, do it well, and be selective in presenting your results. Do not present all the experiments. If you repeated the analysis to do median lethal concentration 5 times, present the one which gave you the best results with the least variation, for instance. Statistical analysis you must do very carefully. It must be well presented in the methods. The last paragraph is normally dedicated to the statistical analysis that you conducted. And using the word significant, you should be very careful. You should try to avoid it in the rest of the text, because significance in our area of research immediately takes you to the statistical test that prove that significance. So be careful about the words that you use, mention all the formulae, use standard programs, and try to avoid over-interpreting data. So just use the data for what it shows. Do not put it for your own analysis, your own ideas, your own subjective observations. Don't do that. Now, if you present your data in the manuscript, it can be presented in the text or in the graphs or tables. But if you have presented data, for instance, as a graph, you cannot present that same data as a table. So be careful. If the data is not significantly different, try to present it as a table. But if you think that it is very important, then present a graph. Be careful about the quality of your figures. Use good programs to prepare these graphs. And we like to use a sigma plot. You can use that. It's possible that your university can purchase one for everybody's use. But it's very important to have programs which will allow you the flexibility to prepare the graphs in a good manner. Be careful that your graphs are very clear, but they are not crowded, that the data is well presented over there, and everybody can understand it. Do not use color, because color is very expensive to print. You will have to pay for it. Black and white is quite adequate. If you need to use photographs, keep it to a minimum. These are some examples from our own studies, graphs and tables. And now you come to the discussion. Most people think that it is a very difficult section to write. It is not, if you think carefully about it. What you should do is to look at all the data that you have and think which points I would like to highlight. Now, the most important thing when you are doing a discussion is that you must compare your findings with other published data. If you simply present your data, it goes to the results. If you simply show what other people have done, that should be in the introduction. But when you compare what, for instance, that you found a species diversity of 1.5 and Sarma et al. Found a species diversity of 2.3, and then you say that, okay, now I think that the species diversity I found was lower because the water body is highly eutrophic, it receives a lot of contamination. Okay, so that is a discussion. So be careful how you write the discussion, generate a few points and work on them. In each paragraph of your discussion, you should have only a few ideas that you are talking about, one idea or two ideas, no more than that, and go to the next paragraph. The discussion, like the introduction, should have about 5 to 7 paragraphs. A maximum of 1,000 words, 800 words is quite adequate. So now you can put in the last paragraph of your discussion a separate section. Some journals suggest that you write conclusions, summary, or a resume. If they don't ask for it, you can suggest, you can write a few conclusions, and you can suggest future lines of research, future studies that need to be conducted in this field. Now you come to the figure legends. You have to write very carefully. If you do not have an idea of how to write a figure legend, study one of the figure legends in a published paper. Look at the style and try to copy the style of writing. That's all. There is no, it's not rocket science, it's easy, but you have to study previously published work. Tables always have headings and figures have figure legends. So do not put a figure legend for a table or do not put a heading for a figure. Now, references, you should place it where it is needed, not at the end of the sentence. Be careful how you write and follow the instructions to authors meticulously. I heard many reviewers saying that they first revise the references. If they find that the authors have not paid attention to the style suggested by the journal, they do not even bother to read the rest of the article or the manuscript. Because they say that if you are so careless that you cannot write the references correctly, as the journal has asked you, then we do not trust your data. So be very careful, be very, very careful with questions regarding the presentation. Cite only the most relevant references. I told you, do not cite too many very old references. Depending on the journal styles, you have to abbreviate the titles. Normally, one-word titles such as science, ecology, nature, hydrobiology, these are not abbreviated. So be careful how you abbreviate these journal names. Do not try to cite too much of unpublished data. It weakens the work. So cite only that which is published in good reputed journals. Restrict cross citations. That is not appreciated. So try not to do or use cross citations. Now you have to be very careful. You must verify all the citations in the text and in the list. They should match very carefully. Be selective in your citations and do cite a few articles from the journal where you plan to publish. The rest of these points we have already discussed. There are different ways of citing: the name and year system, the alphabet number system, or the citation order system. This depends mostly on the journal. Each journal has its own style, and you have to follow that very carefully. Now you come to acknowledgements. Whom will you acknowledge over here? The people who have helped actively in data collection or in the preparation of the manuscripts. Normally, friends and relatives are not supposed to be acknowledged here. Funding agencies, do not forget them, because if you do not acknowledge them, they do not get any credit and they will not fund your research in the future. Now, once your manuscript is ready, let it rest for a few weeks, then revise once again, and keep the following data ready when you want to upload the manuscript in the website: the complete manuscript, the number of words, the number of figures and tables. Reviewers, who do you think can be a good reviewer for your manuscript? Keep their address and emails, because most journals ask for 3 to 5 reviewers. And a covering letter to the editor explaining very briefly what problem did you address, why your study is so new, and what is its importance, and why the editor should accept your paper. So these are the things that you need to write in your covering letter in just one paragraph. Okay, now check for similarity and plagiarism, because it is not that it is you purposely did it, but many people have a similar styles of writing. So check for that before you send your manuscript to the journal. If the journal detects that sections were written using artificial intelligence or sections are very similar to previously published work, you will get a very bad reputation. So be careful. And for language, please ask for help from native speakers or from people who speak excellent English, so that there are less possibilities that your paper should be rejected. Once your paper comes in for review, the scientists have said that yes, the paper is good and we must publish it, but we must correct it. So you will now have to make the corrections, read very carefully, understand what corrections are being solicited, and absolutely stick to those. Do not rewrite paragraphs and discussion and all at this stage, because that will only involve more corrections. So write very clearly what was the comment and what have you done to improve it. That is very important. Now, once the manuscript is accepted, proofs are sent to the authors, and these should be very carefully read and corrected. These, once you get proofs, you should keep the corrections to a bare minimum, so that, because now it is expensive to incorporate all these changes. So just a few corrections which are very, very essential, stick to that. And send the proofs back within 48 to 72 hours, no more than that. Do not be disappointed. This is the most important part of the talk. Do not be disappointed if your manuscript has been rejected. Look at the manuscripts that were rejected. Krebs cycle by Krebs was sent to Nature and it was rejected within 5 days. The PCR reaction, the polymerase reaction by Mullis, it was sent to Nature and Science and both rejected it. Later on, he got a Nobel for this. So that's what I'm saying. Do not be afraid of rejection. Once your work is rejected, do not be sad. Be sad for a couple of days. After that, try to look at it again and read it, improve it, and send it to another journal. If you want to publish for free, there are 2 ways to do it. First of all, check with your library. Sometimes universities make deals with different publishing houses. So they may accept your manuscript for publication without any payment from your side. If you have to pay, it costs a lot of money. It is more than about $50, $100 per page. So be very careful about these details. Ask for help. And if you review for certain journals, they themselves will invite you to publish for free. So think about all these different possibilities for publishing. And finally, I just would like to say that we follow the statement by Ernest Hemingway. He wrote fabulous books, including The Old Man and the Sea. He says very clearly, we are all apprentices in this craft, where no one ever becomes a master. So there is no fixed rule of writing. It is the style of each author, but it should be very attractive and it should be well presented data, and you will have a lot of success. Thank you very much for your attention.
Thank you very much, ma'am. Now the session is open for the questions.
Very good morning, ma'am.
Good morning.
Some of the students, they may ask about cross citation.
Mhm.
So will you please elaborate for their sake?
Yes, of
What is
course. What is a cross citation? A cross citation is when you cite a work which you have read about in another study by another author. For instance, you don't have uh, y- articles by Dr. Sarma, but Dr. Das has read something and she has written a manuscript, an article in which she has cited Dr. Sarma. Now, if you want to cite what Dr. Sarma said, now you are falling into the trap of cross citation. And why do I call it a trap? Because you are now dependent on the opinion of Dr. Das. You have not read the paper of Dr. Sarma completely. So you are limited. And that is why cross citations should be avoided, so that you have access to the original author's ideas and you can make your own judgment based upon that.
Okay, thank you.
Thank you.
Hello, good morning, ma'am.
Good morning.
Ma'am, what about the impact factor? There are many websites which showing the impact factor of your paper
Yes.
and your journal, but which one is?
Web of Science is most standard. Journal citation reports, you can see Web of Science, it's the most standard value. But some people also use Shimago. It's up to you. And some journals themselves write the impact factor in their own page. So
Yes,
you
there
can
is
find.
Yes, there is NAS impact factor and other impact factor also. That means there are certain agencies where they find their own impact factor. So which one is more acceptable?
I think that the Web of Science, but if you ask Dr. Sarma, he will tell you more clearly. But we normally follow the Web of Science, or we follow what the journal itself says, the
Whatever
impact
is
factor.
Whatever it is written in the
In
front page of the
front page of the journal. Because if you go for good journals, no, from good publishing houses like Springer or Elsevier, they are good publishing houses. But if you go for journals which are very little known, they are not well known, then it is a problem.
Yes, yes, I've gone through Cosmos impact factor, NAS impact factor. Then there are several agencies like that.
Yes, yes, yes. Any other questions?
Good afternoon, ma'am.
Good
Ma'am,
afternoon.
I have a question. As you
Yes.
tell that we are supposed to read, whether it is a novel or journals or articles. I have a question ki how we can implement that. I mean, you said we have to learn from that and then we have to implement it. So what are the practices that we are supposed to do?
Okay, I'll tell you. What I mean is that you must develop the habit of reading. So everybody says, I don't have enough time, I don't have time to read. But that cannot be true, because you have plenty of time to see all the internet, right? But that is not reading. You have to take a book, you have to read a good article. You may read it on the internet, but it should be a book. Okay, that's the first point. The second point is that try to spend, even if you can spend 15 minutes every day on focused reading. Okay, so you take an article, you take a book and focus. I mean, don't have any disturbance at that time, just read. Pay attention to the style of the author. How is the author expressing his idea? Is he using very long sentences or short sentences? Is he using very big words or small words? So read only the first paragraph like that. Because if you read the whole text like in this manner, you will not have a love for reading. So the more you read, the more you will learn. It is absolutely fundamental to develop the skills that are necessary to write well. Okay?
Thank you, ma'am. Thank you so
Welcome.
much.
Welcome.
Madam, is it necessary to quote references every time. Suppose a very new idea or a new experimentation. Earlier, it is not been done by anybody. So, if we search, there is no publication or no references are available. So, is it mandatory that references is required to be mentioned in the research paper?
In the context in which you have done the work, you should try to look for some previous research. Perhaps it's something very new, and then perhaps you obviously don't have a reference to cite. But for instance, if you are working on a species that has never been observed in India, okay, but it must be found somewhere in the world, right? So somebody may have done some work on it. So if you have not got any data on that, then you can go to the next level. That means you don't talk about the species, but you talk about the genus. So somebody may have worked on the genus. So some sort of context we must give. Because if you do not put references and you do not give the context in which you are writing that paragraph, it becomes difficult for other readers to understand. That's why.
I believe that it must be the reason that the Krebs paper was rejected. Because earlier there was no work on that.
No, maybe, but we don't know why it was rejected, but it may have been because of that, who knows? But they have their own options, their own decisions.
Okay, thank you.
Ma'am, can you please guide something about a review article, how to write a review article? Our own works, it's much easier than writing a review article.
That is very true. That is very true. A review article, you must read at least 100 articles on the subject, 50 articles on the subject. And the most important thing while writing a review is that you should have an idea of reanalyzing all this literature. For instance, let us see if you want to write a review article on the sensitivity of rotifers to copper. So people have studied copper in different parts of the world, and you can do an analysis of the relation between the body size of the rotifer and its sensitivity to copper. Now, this would be an interesting article because you show different trends and nobody else has done it. So that is what is important for writing a review, to reanalyze and to present new ideas. If you want to see very good review articles, please read Trends in Ecology and Evolution. Trends or annual reviews of ecology and systematics or annual reviews come in many different subjects. And these papers are published based on invitation. So these are by very good, brilliant scientists. See the style, like I told the young girl just now, just read, observe the style of writing, and then you can write a very, very good review.
Good afternoon, ma'am.
Good afternoon.
Ma'am, what are the key points for choosing an appropriate topic for manuscript?
No, you don't choose the topic for the manuscript. You choose the topic for your research. You choose the topic depending upon your interest. Okay. So if you work, for instance, if somebody says that, okay, if I do the molecular study of spiders, I will be able to publish easily, but I don't like spiders. So then I will say, no, I'm not interested. I want to study rotifers. So now you have studied the rotifers, you look at that data, you have a good question based upon the literature, like I told you. Now you have generated the data. Now look for a journal where you can publish this data. That is the process. Okay?
Thank you, ma'am.
Welcome.
Good afternoon, ma'am.
Good afternoon.
Ma'am, I just wanted to ask a question that from where can we access these journals which are reliable?
Yes, that's a very good question. You can access all these journals on the websites. You can look for the journals. India has got access, free access. It has recently developed. Look for famous publishing houses. Okay. And I know that it is very difficult when you are young and you don't know. Ask your teachers if this is a good one. Read the literature, Study the different authors. If you see, for instance, most of the authors you are interested in have published in freshwater biology, in ecology, in oikologia, then look for these journals. Okay? But you have to develop your own database for this point. But look in the look carefully, because nowadays you can fall into the trap of many open access journal that publish subpar research. So be careful, be careful.
Yes, ma'am. Thank you so much.
I think if you have any more questions, Dr. Das, maybe we should leave it for the session after Dr. Sarma so that he has enough time.
Okay, ma'am. Any questions? Any questions from online participants?
Good afternoon. Sorry, good morning, ma'am.
Good morning.
Ma'am, I have one question. As a research scholar, we are facing many problems when we are writing a review paper or research paper. So sometime I'm also facing that when we are writing when we are writing our review paper, then how can we identify the ghost journal or fake journal? And the second question is how much references we need to cite in review paper and research paper?
Okay, I'll tell you the second part of the question. Normally, for a review paper, you are allowed to cite up to 100 references. But if it is an original paper, you should restrict yourself to 50 references. Do not cite too many works because the editors may not like it. 50 to 60 is a maximum. And as for the ghost journals, ask Dr. Sarma that question. He is an expert on it and he will be also talking about these subjects. Ask him about it.
Yes,
Okay?
yes, ma'am. Okay, thank you, ma'am.
Okay.
Anyone?
Okay, so we'll
Okay.
thank you very much. Thank you very much, Dr. Das. And some people have asked for the presentations, Dr. Das. I will talk to you after this event. See?
Sorry,
today.
ma'am. In the morning, I am unable to attend your
call. No problem at all. I will talk to you after the session.
Okay, thank you.
Thank you so much. Thank you very much, all of you, for your attention and for your interest.
Thank you, ma'am. Thank you, ma'am. Thank you. I extend my thanks on behalf of organizing committee. Ma'am Sharma enlightened us and our young scientists, our students, about scientific writing. She, in very easy language, explained requirement of scientific writing, why it is required. She explained very nicely. I think most of our students have grabbed the terms and conditions, what she has explained in very easy language. She updated our information that India is on 4th position in publishing journals. It's a new information for us. And also, India is next to USA in reading. So again, it is a great data for Indians, we Indians, and our young scientists, they should also work in same direction so that we can reach 1st position in publishing journals as well as in reading. She also talked about types of articles like originals, like reviews, like conference presentations. She also explained how to begin writing, what are the qualities to be a good author, designing paper of a title, abstract writing, review literature, material and method, how you can explain your material methods. It should be written in past tense. These are very minute things that should be taken under consideration while you are writing your things. Result should be discussed properly as it is heart of a paper. Discussions should be done with thoughtfully, carefully analyzing all the things. References, acknowledgements, manuscripts, check plagiarism before submitting your paper so that it can be published easily. I think this complete lecture was very knowledgeable and must help our young scientists in their future scientific writings. Thank you so much, ma'am. Thank you on behalf of our organizing society.
Thank you very much for your kind invitation. Thank you.
Thank you, ma'am. We'll gather after 15 minutes of break for next session. We'll all gather here again on 12:30.
Recording stopped.
Good afternoon, sir. Okay, shall we start now?
Yes, I am ready. Thank you.
Okay, thank you.
Good afternoon, sir. Good afternoon, everyone who are presenting here and who are join us online mode. And welcome to our 7 days international workshop on technique in hydrobiology, jointly organized by Department of Zoology and Botany. My name is Om Prakash Miravi, Assistant Professor of Botany. It is our pleasure to welcome our today's guest speaker, Dr. S. Sharma, who has joined us virtually from Mexico. Dr. Sharma is a professor of National Autonomous University of Mexico. He is an aquatic ecologist known for his research contribution in the field of freshwater zooplankton. He is an elected member of Mexican Academy of Science, International Society, London, and National Research of Mexico. He has published more than 300 articles and book chapter. He has edited, co-edited 14 special values for prestigious publishers, which are Springer, Elsevier, Francis, and Taylor. He is on the editorial board of the dozens standard journal, reviewer of hundreds reported journals. He is currently editor of the Rotifer News. Today he will discuss about the topic of how to avoid retraction of articles. It is a very important topic for new researchers. So welcome to Sharma sir to deliver the lecture.
Thank you very much for your kind words. I will start with by sharing my the presentation. Can you see it in the
Yes,
mode of presentation?
yes, sir.
Okay, thank you very much. So, I would like to start with a few aspects. This is not actually our area of research. Our area of research is zooplankton, and Professor Nandini is in our university ethics committee. So she's still in the committee for the last 6 years or so. And then the university authorities have asked her if she can uh, share her experiences in the committee meetings with other colleagues. We have colleagues who have got more than 40 years of experience, have been contributing to the different fields of science, yet they have some problems sometimes about the ethical aspect of manuscript writing, manuscript publication, and so on. So with that experience, Dr. Tandini started giving workshops to our colleagues, and then I joined her. Earlier to this one, I have some experience in informatics. I worked in a company in India, Informatics India Limited, for some time before I moved to Belgium. So that coincided with the requirement of the university, and Dr. Nandini's skills in organizing these workshops, especially on ethics to our colleagues, is also helpful. So we keep on adding in every meeting whenever is possible to increase the breadth of our knowledge in this respect. So here I mention, I deal with the article retraction. This is very important, not only publication. If publication is important, avoiding retraction is equally important. And this is generally
Recording in progress.
This is generally for the senior colleagues who have made some publications already, or those who are planning to publish something, and then how to avoid problems based on what others had suffered from. So I would like to give my talk based on my experience with some of the journals with which I have been associated with. But these are not the only thing. There are many more still. Each researcher experiences, each editor, each member of the editorial board, each author, uh, every time experiences something different. So I would like to share with you some of my own experiences. So there are two terms that you get in literature related to the retraction and retractation, which is the correct word. So both are used in the beginning. That is just withdrawal of an article from a journal. This is in short terms. I give the definition, but these two terms are very common. But which is correct actually? So if you check in the literature, retractation is a legal term usually used in the revocation of some kind of contract. For example, somebody wants to sell the land and then later on he doesn't want to sell the land. There is a contract, but we would like to break the contract by paying some money and so on. These kind of problems usually the builders face. They just want to construct huge commercial complexes or housing complexes, but the landowners initially say, yes, we would like to sell. Later on, they withdraw their contract. This is called retractation. Now, retraction is usually a withdrawal of a statement, not rather than a contract. In this case, is more applicable for research articles. Now, if you go to the definition, retraction simply means removing an article from a scientific journal or a record at any time only after its publication. During its process of publication, it is not considered as a retraction, it is considered a withdrawal. Okay, but we also believe when an article is published forever, it survives in literature, it could be 350 years old, like Dr. Nandini mentioned, the Philosophical Transactions of Royal Society started 1665. An article that published there is still valid, still living, and you can still read and cite. However, retraction is the one that kills. It is some kind of a death sentence given to a published article. Now, which are the journals that have this problem? Most journals in the world have this problem. It was not detected before, but because of the artificial intelligence, ChatGPT and so on, and then authors don't really write, they get the articles done by artificial intelligence programs, and those are not considered to be original work, and therefore they get rejected, or if they are published, they get retracted. Now, therefore, if you see the journals like Nature, some of the prestigious journals in the world, Science, Proceedings of National Academy of Sciences, Lancet, and these are the top level journals with an extremely high impact factor. They all have suffered retractions. But what happened to the editors? What happened to the reviewers? What happened to the authors? All these are involved in this process, yet they pass through all these processes and eventually surface in the literature, and somebody detects and then suffer the article retraction. In addition, some of the famous researchers or even Nobel Prize winners also have suffered retraction. They themselves retract or somebody else suggests to retract. Now, sometimes you also get some names wrongly printed by the journal. These are not serious errors. See, the journal makes a publication and then unfortunately some mistakes happen. It could happen in the title of your article. It could happen in your own name. Here is a good example of Hanazato. Instead of Hanazato, it is published in Hanazato. I don't know why he is the first and corresponding author. Somehow he did not check his own spelling, the spelling of his own name. And then it was published as Nanazato. And then somebody detected it and told, hey, you're not the same person as another person. Then he said, no, this is me only, but what I do is I'll have to write a letter to the journal and the journal corrected it called erratum. But this is not an offense. It is an error, but it is not an ethical issue. So it can be corrected easily. Whereas retraction, if it is done, it cannot be corrected. We will see. How can we distinguish whether an article has been retracted or not retracted? As Dr. Nandini mentioned, it's always a good idea to consult the original literature, original article. If you see the side references, you will not know whether it is retracted or it is really functional article. Here you see, when an article is retracted, the journal puts, after its publication, journal puts the letters in red letter, retracted. All of them use the same word. All of them use red letters also. So First page, sometimes some journals it appears in the article, the first page of the article it appears. For some journals it appears in all the pages, because it could be also misleading. Only first page has a retraction, other pages no retraction, and you consider that other pages are valid. No, the cancellation of the article starts from one page of the article to the last page of the same article. This is generally most journals follow, but some of them follow only the title one. This is depending on it. Some journals also indicate only in their contents. So these all happen before, after the publication. Before publication, the journal article looks like completely normal. Okay. Now we go to the next one. As I mentioned, that publication, once an article is published, it survives forever. That is our normal belief. But it doesn't die, but it can be killed by the legal hanging or by what we call a retraction. Once an article is retracted, you cannot cite that it is not a part of the literature. But anyway, I'll just come with that point later on. But if we see the first historical perspective, the first retraction by Galileo. Galileo said there are two terms that use geologists, geocentric and heliocentric. Geocentric means the earth is the center and sun moves around. Heliocentric means this, the sun is in the center, earth moves around the sun. So in good olden days, Catholic Church in Italy did not believe the earth revolved around the sun, that they did not trust. But Galileo trusted. So he said publicly that this is heliocentric point of view, which must be respected. So the church jailed him. Because of the old age, they put him in the house, but again put him in the house arrest, and finally died when he was in the house arrest only. So he did not change his opinion, but they forced him to change several times. Eventually, they wanted him to retract. It didn't happen eventually, or at least forced to some extent. Now, the real retraction of the opinion happened in 1756 in the Philosophical Transactions. There are two famous persons, Benjamin Wilson and Benjamin Franklin. Benjamin Franklin, you probably know very well. And the articles of Benjamin Franklin were not trusted by Benjamin Wilson. They were friends together before. Both of them are members of the Royal Society, fellows of Royal Society in London. But somehow Wilson did not believe in the beginning the articles, the opinion of Franklin, and then much later he retracted his own opinion. When he retracted his own opinion, it got published in this journal. Now, since 2012, and Foreman has made a summary of many retracted articles, how they are all retracted. This information is available in detail. And now, unfortunately, Proceedings of National Academy of Sciences has published an article stating that since 2007, there is a global increase in the retraction, in the number of retractions. Independent of the area, all over the world it happens. It has been happening. This is because people are aware, users are aware, which is copied data, which is unethically collected data, which is written by artificial intelligence, and so on. Okay. Now, there is another word recently developed that is called expression of concern. It is not a retraction, but it's some kind of warning. So expression of concern is issued by a publisher or an editor stating that he has got some serious concern about some articles in the journal. And that statement they make in the journal itself so that the reader should know about this one, that some articles have got serious problems, but they do not have sufficient elements, they do not have sufficient evidence to retract the article at that stage. However, if they have further evidence that the authors have copied from other source, then it can lead to retraction. Here is a recent example of Adel, one author from the United States. He has got double affiliation. One is in Florida, another is in Miami. He had published 375 articles or so, or even more, of which 116 appear in a single journal. This is the American Surgeon Journal, and the the editor detected some anomalous writing in this manuscript, in the articles. Therefore, he said this is expression of consent, but he doesn't have any evidence because it is properly reviewed. It might be a manipulation of the reviewers, but still it could not be definitively established. So they suspected that it could be a case of expression of consent, and it is left at that stage. Still, investigation is going on the background. Now, expression of consent legal terms equivalent to sometimes the judges in the court, they have reasonable doubt that that somebody has taken. Usually, it happens for the politicians. They take bribe, but they don't. But we have no evidence that they have taken bribe. But we know that they have taken bribe because before election and after election, you see the property they have could be 10 times or even more. So something unusual is happening with their property. So the judges believe that yes, there is a reasonable doubt, but they have no evidence directly to convict the accused. So this is the same thing for a journal. Expression of concern is the same. We know that there is some problem with the manuscript, the article published in terms of the data or some other thing, but we have no evidence from where he or she copied the data. So now if you see the global trends, as I mentioned, that it has been unfortunately increasing all over the world. And the largest retractions unfortunately happened 2023 and 2024 data we do not have. I'm waiting somebody to write an article to utilize that information. Then Institute of Electrical and Electronics Engineers of the United States is very famous. It has retracted more than 7,000 works in the last 5 years. Unfortunately, the reviewers failed, the editors failed, the associate editors failed, and the whole team of the journal management administration failed, and therefore they had to withdraw. And some authors published it's nothing unusual, and some every 5 years. By Saturday they communicate an article. Monday they start working. By Saturday an article is communicated. So if that is the velocity of article publication, somebody could suspect maybe something unusual in this. So if you go to the large scale retractions, go for example, Nature mentioned about nearly 14,000 retractions have happened in the of articles published during 2023 all over the world. And unfortunately, 75% of them have Chinese co-author. We don't know whether Chinese is involved and created this problem, but somehow the Chinese co-authors are involved in more than 75% of the retracted articles. There's something suspicious is going on. Dr. Nandini already mentioned. About so that Nandini already mentioned about this aspect that Chinese researchers have overtaken the United States in terms of number of publications. We really do not know if that is related to some kind of restriction is also involved that requires more analysis. And countries, the largest retractions you will see, China ranks 4th undoubtedly, and India is also trying to compete to gain this kind of dubious distinction. And Saudi Arabia is the one which is known for the largest number of retractions. In terms of every 10,000, 30 articles have been retracted. This is what we know. And Pakistan, Russia, and China, Egypt, Malaysia, Iran, and so on. So they all have different degrees of share in retractions of the world literature. Something anomalous is happening in their works. Now, Saudi Arabia, why it has landed into this kind of problem is because of false authorship. 56 articles in a single stroke were removed from a journal because their co-authors were added. Dr. Nandini mentioned already, this is an ethical issue. You cannot add co-author name of any person, any colleague, if he or she has not done anything. If that is added, then it becomes more complicated. You can add the entire classroom as co-authors and publish an article. That is not correct one. Ethically is incorrect, and if somebody detects that could lead to retraction. What happens in this case is that in Saudi Arabia, for a medical degree, every medical student should publish an article. If he has not published, he or she, if he has not published, he will not get the degree. Therefore, for one article, they keep on adding the dozen students because all of them should get the degree. And somehow this truth came out. And then some of the authors mentioned, co-authors mentioned, hey, I have not contributed to this article, but my name appeared and somebody put it there. Maybe a corresponding author has added. So anyhow, one of the authors indicates that his name was illegally added to that. That is sufficient element to retract the article. So there are several steps that I will mention now. Before that, I would like to take you to, this is genetics paper. This is another problem. Do not fight with the government. What happens in this case? Chinese researchers went to the this Tibet. They consider as a part of their own land. It's okay for me. It's not a question of contention on this platform. But they have taken blood sample from 120 typical Tibetans, and then they found that their DNA is different, and some conclusions were there. You will see that the problem with this one is that if they say that their DNA is different, then Tibetans will say that we are a different population and we are occupied and so on, they can create some problem. But if they say that it is very similar to other Chinese nationals, then they fight with that, no, we are different. Either way, it is a problematic situation. Now, what happened here is government somehow wanted to suppress this article. Chinese government came into play and then demanded the journal to retract because the blood samples taken from the persons, the Tibetans, were not informed. For what purpose you are taking the blood sample? They were not informed. Is it that just to know the blood type or some other reason? So they were not informed. That is a pretext, or that is the reason why the Chinese government involved in this one and forced the journal to have the retraction. So sometimes the governmental agencies involved in this kind of process as well. Now, the Lancet has detected also 10 years old information on an article published 10 years ago, and 10 years later, they detected some kind of duplication in the publication. One article was published earlier with some data. You will see some of these authors again of Chinese origin, and then whatever may be the reason that they consider the duplicate data appeared into different articles, into different journals, into different periods. So retraction can be done at any time, even if it is 20 years, 30 years, 40 years old data also, that retraction can be possible. But there are certain other conditions you need to fulfill for retraction to be effective. So this is a prestigious journal, you know, it is one of the, some of the impact factors of Lancet, for example. Those who work in the medical field know, and it is very extremely high. Is nearly 170, and 2 years ago it was 240 or so. It fluctuates a little bit, but never falls to very low level. Okay. Now, this is another colleague from Bangladesh, and he apparently he is a computer scientist and has got a good knowledge of computer software programs and so on. And Muhammad Shahuddin has published more than 100 articles when he was in the Southeast University in Bangladesh. That must be appreciated. That's the thing. But there is a problem. 130 articles that he published in this very short period of time, it caused problems because usually people who check your CV, they check if you have a 300 articles, you have at least in seniority in science, maybe 30 years. Otherwise, it's not possible to publish so many. And in 5 years, he published 130. In 10 years, maybe 200. In 5 years, could be maybe 1,000. So this causes some kind of concern for the users. Sometimes users they act as spies. So in this case, somehow the Web of Science detected that there is some problem with this number of extreme high publication rate, and then they check the citations also the very high, and then they check the reviews on Pablones, and then they are all acceptable. Somehow they cornered him, and they said, look, there's some problem with your article. So what is that? He admitted he has done plagiarism, that is stealing from self-plagiarism or this called auto plagiarism, or you can also collect data from another article or your own article and put as a new something. So at least 60 of the articles he admitted, but very cleverly, every manuscript when you submit to a journal, it passes through a kind of anti-plagiarism detection program. There are about 30 programs available commercially. Most journals have 4 or 5. Our laboratory also, we purchase on our own, and then we check the students' thesis. Sometimes they copy from some source and then put us into problems. So we check the thesis completely. Our university also does, it has its own programs apart from our individual programs. And now this is what it does is a paraphrasing software that it takes one sentence from one author, another sentence from another author, third sentence from another author, and put all the 3 sentences into one and put the author's name, your own name. So this is a mosaic type of, this called mosaic plagiarism is common, and it is done by artificial intelligence very fast. So many software programs, anti-plagiarism software programs cannot detect this one. Who can detect? Only a subject expert who is reading this one knows the first sentence is said by X, second sentence said by Y, and third sentence is said by Z. And now we will come to know that this man has copied all the 3 sentences and owned the 3 sentences as if he has said it. So this is the thing that it causes some kind of alarming among the scientific community if you make enormous production in a very short span of time. This is now Mexico is not an exception. I do not have to say that other countries are responsible. We also have this one. This is a conflict of interest. You will see here an article was published in 2020, and it said there are several authors, 2 of them, all authors collectively have said that COVID infection is less frequent in smokers or tobacco users. But in reality, the smokers are the ones who suffered most because respiratory damage has happened, happens with the smoking, and this COVID virus specifically attacks the respiratory system. And that is why India, like many other countries, during the peak COVID time, we had a shortage of oxygen. That we need oxygen, they had problems with the respiration, they could not respire. And this is the problem. So people suspected, how is it possible that the smokers survived better than non-smokers, especially with reference to the COVID? So this doubt appeared in literature, appeared in magazines, appeared in daily newspapers, and so on. And finally, they detected that these 2 authors who are in the these 2 authors are from Mexico, but there is a problem. They are funded or they are receiving salary from a tobacco company. Therefore, they have to write, at least people believe they wrote in favor of the tobacco company, because if they write that smokers die faster, the company will throw them away, will not give them any funding. This is a belief that many people had. And then finally, the editor-in-chief detected that these authors did not disclose that they have a conflict of interest because they are funded, they have received funding or salary or some such thing from a company in monetary benefit that they have to disclose. When they check the letters to the editor first time when they wrote, as Dr. Andini also mentioned, this is very important, your first letter to the editor, what you have done, why it should be considered for a publication. In that case, in that letter, they did not mention that they work for a company. And this is what is called conflict of interest, has not been disclosed by the authors, and the article was retracted. Now, which field has more fraud in science? You see, social sciences are extremely low. We must congratulate them. I don't know why. And also arts and humanities are also extremely low compared to biological and medical sciences and multidisciplinary sciences like engineering and so on. But other fields generally are lower. So these 2 fields, more articles are published, more articles are also retracted. This is mainly because a demand from these institutions where such research is done for more and more articles, and authors try to create more and more false data or copied data and so on. Okay. Then comes global view. What are the components in retraction. Please do not copy this one. We are planning to make some chapters in the future. But I would like to give you a panoramic view of an article retraction and its elements. You can also have self-retraction. You can also have false reviewers. It's very common false reviewing. You put you create email addresses of some well-known persons. There is a company that charges you $50 and give you 10 email addresses in the name of a person. I can create email addresses, Gmail addresses in the name of your principal, in the name of your rector, in the name of your dean. It's very simple. But he is not the real person, but only the email addresses appear to be as if your dean has this email. So the professional enmity is another problem. And these are vigilant people. They don't publish properly, but they know who has published and immediately try to retract. Ask for the journal to retract. And the lack of data reproducibility is very important. You publish an article and ask for the raw data. Somebody asks the raw data, yeah, I need the data. I want to verify whether your statistical analysis is correct or not. If you fail, then article is withdrawn later on. And retraction, remember, retraction applies to all authors. If you have an article has 1,000 articles, 1,000 authors, co-authors, all of them will get the same treatment. Article is withdrawn means all of them suffer. Then this is another problem. The unethical problem is happening these days. A retracted article should not be in the literature, but unretracted version, that is just before retraction, maybe the article in the normal form, they upload into the internet. Students who are lazy to consult the real literature, they do not go through the journal, just see only whatever is available in the Google, as Dr. Andi mentioned also about it, simply they download the article and cite it. And sometimes after retraction, the number of citations is higher than before retraction. You will see that one. And violating human rights, animal rights, this is very common. As I mentioned, one example that Chinese government said that authors were not, the people were not consulted for what the blood samples were taken, and then they finally it got retraction. And the retracted article continued to be cited. It's not good, but authors do not bother about it. And the retraction of abstract is also possible. And the media outrage is very important. This I will deal with some of them which are yellow in color. I will deal with them. And if the article has got grave errors, mistakes that cannot be retracted, that cannot be corrected by any means, and even common man knows there is a great error, and that suffers a retraction. And in some cases, very few, retraction and republication is possible. And who initiates the retraction? That comes the next question for us. But what are the most common reasons for an article to suffer the retraction? Number one is scientific misconduct. What does it mean? You copy the information from your colleague and don't put his name, for example, is one. And failure to provide basic information, that you provide a lot of data, lot of graphs, but somebody will say, provide me the raw data because I want to reanalyze the data. You won't provide. Then you inform the editor-in-chief, the author has not provided the information. Then article suffers a retraction in course of time. And the problems with the reproducibility of the results, you try to repeat what others have done. You said that you have found a new species in a given water body. I go and collect the same water body, zooplankton in the same water body. There's nothing of that kind I find, and I will communicate to the editor-in-chief stating that I also collected thousands of liters from the same water body, and this is a very common routine for species, and nothing unusual was shown by some X previously. Then the editor-in-chief consults the author, and if author fails to provide the specimen or so on, then the article suffers retraction. Then there are serious errors sometimes. Then illogical interpretation is also called misinterpretation of the data, can also lead to retraction. And forgery, fabrication of data. Now we have got ChatGPT, then can create thousands of sets of data and in a very short span of time. And if you use inappropriate language, also can suffer. This is very important. Dr. Nandini already mentioned about how you have to address your data, your results, how you describe. And then fake reviewing is another problem. This is common in mostly reported for researchers from Iran. And then they don't do any punishment to the authors apparently, and then they continue to do this kind of things. And plagiarism and self-plagiarism as I mentioned already, duplicated concurrent publications. When both Dr. Nandini and myself, we are in some different journals in the editorial board. One Chinese author has submitted a manuscript at the same time to two different journals, and Dr. Nandini received one for evaluation. The same manuscript I received for evaluation. This concurrent publishing, concurrent sending is unethical, but we found one such case. And professional enmity, there are some people who look the opportunity to bring down upon others to see why they have published. And predatory collaboration and is another problem that you do not collaborate with your colleague because your colleague is not influential. But you collaborate with somebody else, but use your colleague's data. There are some examples. Some of the famous people were caught in this one, and ethical issues handling. The Human or Animal Rights Commission in India is very strong. Also in Mexico, so they can simply force you to withdraw the article, to retract the article, not withdraw, to retract the article. And copyright infringement, the journals insist on certain things. You pay money for example, the journals like Nature. If you publish one article, it costs you approximately 900,000 rupees. 900,000 rupees is close to 1 million rupees for one article. So that's the cost. And if you agree to pay and then later on you do not pay, then the journal has a right to cancel your publication or even retraction of your article. And you have to declare conflict of interest when you are submitting an article. As I mentioned, this is an example, and other related stuff. But here is an interesting one. A German scientist has got a record breaking of nearly 200 retracted articles. He's still publishing. I don't know how and how it is permitted and so on. Now, another such thing is Japan. Fuhi published nearly 170 articles, and he involved two of them. That is, you will see here, he is a first author, and then he involved these two, stating that, hey, join me in the article, we can publish it. These two joined him and detected the fraud. The data are fabricated based on a few individuals, but they said they enhanced it to maybe 1,000 individuals. So in order to have a statistical resolution, but they were caught. They're all data fabricated, no such thing like what they mentioned in an article, and then all the articles were withdrawn. Not just one, 172 articles in this case, and nearly 200 articles in this case. And there are also from Australia and from Japan, and then from Iran is, as I mentioned, in the physics fake review. They put their own colleagues' names, sometimes their own names, but create emails and Gmails and somebody else, and then some famous people. They themselves received the manuscript for reviewing because they have the password. They created the email, but in the name of somebody else. Okay, so this is also common, and then but they're caught. Well, the consequences here, as I mentioned, that some of the articles were uploaded. Some of the articles were uploaded in literature. After they suffered retraction, they should not upload. But authors say, no, we have not uploaded, somebody else uploaded. We do not know who uploaded. But what is available is after retraction, the articles are still available in Google, and you can download and start citing. This is an example, as I mentioned, that before retraction, it has nearly 250 citations, and after retraction, it has 800 citations. I don't know how, because the authors should have withdrawn. Authors say it is not under control, somebody else did it. We don't know the truth. Now, retraction, other characteristics, quickly I go through because there are many here. And it's a legal death of an article, and it is not possible to undo. But recently, we have found 2-3 cases. The legal threat to the journal, it can derail the whole process. This is something that we have recently seen. And then, as I mentioned, the retraction applies to all authors, not the corresponding author alone. If there are 100 co-authors, all of them have the same problem. If one of the co-authors, 1 out of 100 say, hey, there is a fraud in the data, finish. The article suffers retraction without any other consideration. Okay. Retraction can still happen if co-authors do not agree. It generally happens in legal terms, right? That a murderer says that he has not murdered, but he agrees, he doesn't agree. If there is evidence, finished, that the judge has to punish him. So this happens also for a journal. Author say, no, we have not fabricated the data, but still the indication from the article suggests, the indication suggests that they have taken the data from some source, or statistically is not correct, or the data collection is not ethical, and so on. It still suffers retraction, whether authors agree or not, it doesn't matter. Okay, then retracted article should not be cited, but is being cited, and this normally treated retracted data as a part of invalid literature, so it shouldn't be cited. And retraction is possible only when the article is in the public domain. That means that it is available in the form of PDF or any other form in the open access. Directly you can download, or you can pay and then download. That is public domain. That means available for everybody, with or without cost. But if it is still the article is not in this form, that is inside the journal itself is in the process, and then that is called withdrawing. That is not considered to be a rejection. Rejected, that is not considered as a retraction, but considered as a rejection or withdrawn. And as I mentioned already, retraction can happen at any time after its publication, maybe after 10 years after its publication, 20 years after its publication, during the proof stage, during the corrections of the proof, anytime it can happen if it is detected. Now, there are also some consequences of retraction. These consequences, for example, is a permanent mark in literature, is an academic dishonesty, and you should not be consulted once an article is retracted, but it is not done, and it reduces the value of an institution. Some institutions have got more retractions than other institutions, and people don't believe that institution anymore. 2-3 universities in Iran, they have this kind of black mark. And then what is the cost really? One estimation from the United States says that each article that published already, but suffers retraction, it costs on the part of the university nearly 400,000 US dollars. That is a huge amount of money, because salaries of employees, the salaries of the teacher, researcher, and the material that you used, and the equipment that you used, electricity, water, everything that you used is calculated per article, and this is the cost. So it should be taken very seriously, not to make any unethical issue or something that can cause a retraction. And some authors may lose their jobs, some internship, some intern staff members, if they have this problem and they don't get any more the job, permanent job, and then they will be thrown away from the institution, and they cannot get some kind of new manuscripts, and they cannot review manuscripts, and sometimes they lose also the degree. There are many famous persons who lost their title, the doctoral degree, because they have plagiarism. And this aspect of plagiarism I do not deal with now. It takes another hell of time. This one is, you can see this original work that we have developed, that you can see what exactly happens when an article is published. When an article is published, it is in the public domain, right? So when it is in the public domain, somebody reads it, because that is the idea of an article. People read it, and those who read could also be the researchers. So they try to repeat what you have done it, and the data fails reproducibility. So then they become the plaintiff in legal terms. So they are the people. If they consult directly the authors, hey, you have done some mistake, I cannot reproduce what it is, the authors will be very angry to respond. Sometimes they don't respond, sometimes they insult you. So you don't worry about that. You directly write to the editor-in-chief. This article has got fabricated data. It does not reflect the truth in a particular field of science. Then the editor-in-chief has to consult the authors. If the authors they ignore the editor-in-chief's article, letter, or if they don't respond to him properly, or if they respond unsatisfactorily, that is only a part of it they respond, then others they don't respond. How did you collect the data? They don't comment on that, but they say that we have made good analysis, statistics, and so on. So if that is the case, the manuscript will suffer retraction, because the judges here is the editor-in-chief and the editorial board members. Not one person takes generally, but the editor-in-chief consults all the editorial board members, including the handling editor and then take back again, read all the comments of the reviewers, and then they reanalyze the information among the board members and say, no, this author has fabricated and he suffers. So this becomes, author becomes accused, and this becomes, or whatever you call legal terms, defendant or appellant, and then this becomes plaintiff, and there is a war between these two for every article. If the data if the data shown in the article does not fail, then there is no such problem. Now, but there is a problem here. There is no Supreme Court. Beyond what we have, the academic justice is only the editor-in-chief or the publisher, no more than that. But there is a problem now here, that civil courts are threatening this entire process. Okay, now we have seen here one example. Harrison published one article. No, Harrison published one article, and authors review, some readers, they said, no, the article must be retracted because it has got a lot of errors. And then the author said, hey, I'm going to put a case against you, against the journal. The journal doesn't want to fall into the trap of sending its own lawyers and then finding out in the civil court it is a headache. They simply said, okay, we are not going to withdraw, we are not going to retract the article. Now the pity is like this. The article first was published, then it was threatened for retraction, and again it was republished and is now available online. So it means it was not first retracted, then again published. So what are the limitations of our retraction process? First of all, there must be a compelling reason. Anybody cannot say, hey, retract the article of my colleague. That is not possible. You must show academic argument for that. And the editor, sometimes some journals, editor-in-chief knew that some of the articles published in their journals need a retraction, but they don't want to do it because it brings down the value of the journal. Though simply, they say, no, it's common, this kind of errors in most articles. If you want, we can write one correction in that in the next issue, but we don't do any retraction. And the different laws are there for retraction. Different journals use different styles, different authors use different, editors use different terminology, and there is not simply a very strict rule for everything. It is relative, depending on it. There is some agencies for ethics. They formulate some laws, but they are not that much strong enough for us. Each editor-in-chief has his own methods sometimes, and it's not very clear for many of us. Retraction is possible only in the same journal. If the journal was not anymore existing, for example, you publish an article in a journal, false data, but the journal disappeared due to some reason. More than 100 journals indexed in Web of Science disappeared during the last 5 years. Nobody knows why. The people who started the journal, the company who started the journal, took huge amount of money from the authors and then disappeared. And these journals are indexed in Web of Science. They have an impact factor as well. But what happened to the fate of the journal? What happened to the fate of the manuscript? Nobody knows. So this is another problem that we have with reference to the some of the journals, but it doesn't happen with the very standard journals. Anyway, retraction cannot be possible in another journal. For example, your article is published in Hydrobiology, then you write a letter to the editor-in-chief to Freshwater Biology, stating that this article has got numerous errors and then mistakes and then grave aspects, and it can threaten the science. So retract. No, that cannot be done. It should be done in the same in the same journal. If the journal doesn't exist, you can't do any more retraction. And retraction also fails if the original journal doesn't exist. If it modifies, yes. But some normally editor-in-chief must seek explanation from the authors why their article should not be retracted. They must answer. There are many other reasons as well. Then authors must clearly mention why they consider it should not be retracted. And the retraction fails if original authors of an article are no longer. For example, there are 20 authors of an article, all the 20 die. Now you detected that there are mistakes in the article and write to the editor-in-chief, now retract the article. He cannot do anything. This is very similar to the law that we have. If a defendant dies in the jail, the case is considered to be withdrawn. right? This is no more they proceed against a dead person. So there is no posthumous retraction. There is no posthumous punishment also for a criminal. So if he's dead finished, the case is closed automatically. This is a rule for most judicial systems in the world, and authors will have the right to publish non-controversial part of the data. For example, data 3 tables were taken from some source, but 4 and 5 tables are original. Okay, write another article using tables 4 and 5. This is possible from a retract article. This is not very common, but it is not impossible. Now, as I mentioned that retraction, some journals indicate only in the first page, but not all the pages. This is not good because now some journals have decided to include the word retraction in all the pages of the article. And but one more thing, that original reviewers who reviewed the article and finally the article is published, they are not responsible for the article is retracted or not retracted. They have done their duty and washed off their hands. And some retracted articles are uploaded to the databases time and again. And there is another term recently appearing, retraction and replacement. So I retract the article, author say, but I replace some part of the objectionable material I remove and publish it again. It is possible. There is another problem, retracted article and non-retracted article, they have the same, that is an article which was published for, it has got a DOI document object identification we have, but there is after retraction also it continues the same, so it is difficult to distinguish what is what. Now the second part is very important, who initiates retraction? Author himself can say, hey, I found some more mistakes in my own data, I withdraw, I retract, not withdraw, I retract, is possible. And user, you could be a user of a manuscript of an article and then say you initiate this process, write to the editor-in-chief, retract the article. A hostile investigator, there are some investigators researchers who do not do research. Their duty is only to find mistakes in others and then try to retract the article. That is their achievement. Then editor-in-chief, of course, he has a he's a supreme commander-in-chief of the journal, and then he can read the article repeatedly after the article is published, and then if he is not satisfied, he can initiate the process of retraction. The company also can do, there are several companies, for example, if you write against any company in a journal, in an article, as an article in a journal, the company can punish you. There are some cases where at least 3 publishing companies do not publish any more article from a researcher from Brazil, because he wrote that these companies are charge a lot of money and then they make more money and so on, and then they didn't like it somehow. So they said each journal, each of these publishers has nearly 2,000 journals. So 6,000 journals in all 3 publishers into 2,000 each, and on average, 6,000 journals he cannot publish anymore, and he has to look for alternate journals. So do not write something like that. Dr. Nandini commented on letter to the editor, letter in the article, text in the article should not be anything that can cause a reflexive damage. Then the university also can start. Your institution or university can also start to retract the article of my colleague. This is not correct. The government has already mentioned in this case, Chinese, I gave an example of Chinese government, or even general public or social media. This is becoming social media very big threat to science. They have, with the time, they have less faith in science because fraud is appearing and surfacing every day in 1 or 2 articles or even more. This is becoming problematic, especially after COVID, because many authors have said, take this medicine, COVID will vanish, take that medicine, COVID will vanish, and so on. And somebody says, use the traditional medicine, use some kind of seeds, and use some kind of liquids, and so on. They're all false claims, unfortunately. And the social media started revolting and exposing such false things, and then this is a big problem now. Now, here is a university started. Osaka University said that the researchers made some grave mistakes referring to insulin, and then they forced the authors to withdraw. The authors say they belong to the same university. It started by the rector of the university, the dean of the university, but they didn't accept it, and there is a problem between them still. It is not resolved until I know. And predatory collaboration means you ignore the original author that who has made contribution to the manuscript. Maybe he collected data, or he do some figures, or he collected the samples and then analyzed it partially, quantified the zooplankton abundance or something. But you don't want to keep his name there. Keep somebody else who is more powerful in publication, or who is editor-in-chief of a journal, and then try to put his name. And this, if it is known, then you're caught. The article must be retracted. But in many cases, it is very difficult to prove with whom you are collaborating, who has done the work, or who was initially responsible for the manuscript. This aspect sometimes is difficult to prove. And the predatory collaboration also can lead to retraction of the published work. And this is another, Dr. Nandini already mentioned, you do not include a co-author who has worked for the manuscript but don't include and they remove him, and you publish a single author, for example. And what about the colleagues that have contributed the manuscript? No, because you are the boss or you don't consider them worth, but that is not correct. This is an example. It happens unfortunately from Mexico. And what happened was the authors published an article here, and they did not include one co-author. And co-author detected after the article was published. He said, hey, it's my data. I put my time to collect the data, and why my name doesn't appear there. And he wrote to the rest of the authors, and then if you don't retract the article, I'm going to write it in the journal. So the authors wrote to the editor-in-chief stating that we have committed a mistake and we omitted an author name, and then therefore please please retract the article. We will write another article. But I don't know what happened after that, but this is the situation. And you might think that thousands of theses were done nearly 100 years ago in different universities, even in India, right? So you might think that I copied the thesis for very old thesis, 50 years old thesis, I copy, and then submit as my own thesis and publish an article. Don't do that one. That's a grave mistake. Here's an example. It happened from this Professor Daria copied from a thesis that was published. Thesis was published, obviously. The thesis is an unpublished thesis. Was presented or submitted in the year 1968, and then what happened? Somebody detected and said, the 50 years old data, the thesis information the author copied and published, now the article must suffer retraction. Indeed, the article suffered retractions. Therefore, do not try to cheat by taking the old thesis information. Somehow it will be caught. Here is an example of a Nobel laureate who she committed a mistake. She said she published an article, very prestigious journal, Science. Here you will see the article Science, and then a novel method and a very important method for antibiotics and all. She got a Nobel Prize in chemistry as well. It is in Spanish, but it's a Nobel Prize in chemistry as well in the year 2018. And then, but she's unable to, her colleagues, her own people who work in the same institution tried to replicate and then failed. And then they asked her, what happened? Why you could not? She said that the student has some notebook. This is called logbook. Usually it is followed by people who work in molecular biology and biochemistry. And then every data information, every set of information that they observed, or they have to note in the logbook. And the logbook must be under the control of the professor of the laboratory, or the in charge of the laboratory. In this case, unfortunately, the student who had the notebook vanished from Science, and she could not trace him, and he did not have the book anymore. Therefore, the book has got some data sets which are necessary to replicate the data, and could not find, and therefore she said, I could not anymore trace the original data in the book. Logbook vanished. Therefore, I am going to withdraw. She said it's painful to admit it, but it is important that others do not commit this mistake, and they do not unnecessarily waste their time in repeating. And this is an example of collaboration, bad collaboration. This researcher from the University of California State collaborated with somebody else from Canada. This Jonathan is famous for fabricating data. In 17 or 18 of his articles, people detected that he has got fabricated. He suffered also retraction. But unfortunately, she was not aware of his background, and then she collaborated, with this man, and then he also fabricated, is a habitual offender of Science. So he keeps on collecting gathering data, rather creating data, fabricating data, and submitted for this lady. And she collaborated with that, and then they found that the duplicate values in many cases, and then finally she was forced to retract the article. She says that retraction is to correct the scientific record so that others don't fall into the trap of the old and unacceptable, unverifiable data. Therefore, the lesson we have is do not collaborate with the habitual offenders of science. There are some people you have to read before you collaborate. Yeah, he has published 300 articles. Let us go and join his lab. No, don't join, because see his background. If they have, if he or she has got this kind of retraction record, avoid that thing, because you will also be in one of. This is also another Max Planck Institute, very prestigious institution, and he also had detected some errors. Somebody detected and then could not correct it, and then he said, honestly, I admit my errors. And then the authors, the editors said, okay, you are a very honest person, so you retract the first article, correct the article, correct the manuscript, and now submit it. And then they have given the opportunity. So even if you have committed a mistake, you have to correct it. That is our duty, and not to contaminate the literature. Sometimes your own students detect errors and cause to the tune of retraction of article. Here an example, and Professor Helene published an article with some colleagues. One of his students, Leon, he is very strong in statistics and literature and all. Sometimes students read more than the professor in particular area. That should be the trend, because they are specialized in particular. They are specialized in particular theme. So he was reading the published article of his professor, of mentor, and then detected that the critical statistical error in her methods in her article, and the conclusions are based on the statistical error. Therefore, the errors are the conclusions are erroneous, and then this led to, she detected this one, and then led to article retraction. And now we know that good PhD students are worth their weight in gold. If the person is very heavy, gold is very heavy in academic sense, that they read a lot sometimes, and they are helpful. The mistake was that she has not shown, she has not shown she has not shown the manuscript before its publication to Leon. If she had shown that, she could have pointed out at that time and avoided the embarrassment. Anyway, now this is the third one, is a professional enmity. As I mentioned, that some people do not publish anything. Sometimes they keep on watching what others are doing and try to bring them down on some pretext or other. Here is an example. One attempt was made for an article published by Bangladeshi researchers, and then one colleague from Europe wrote to the editor-in-chief. I'm part of this editorial board for a very long time, still on this board. And then editor-in-chief doesn't know what to do. He wrote directly to editor-in-chief stating that the article is erroneous, withdraw it, retract it. The editor-in-chief said that, how can you withdraw? How can you retract it? So I need to consult my board. So he consulted all of us, and then we suggested, let him write an article in the form of an article, all his objections and the reasons why the manuscript, why the article should be retracted in the form of an article. What do you think? He has no data to show. So he just failed. He was afraid. Actually, he was insulted, and he could not provide the data. And therefore, he demanded retraction, but did not happen because he lacks basic information to argument. Now, this is the last part of the information. There are some external forces that cause retraction. This is very important to know. This is related to write-up, and Dr. Nandini already mentioned about this. Look, a very good article, mechanical, biomechanical characteristics of hand coordination, extremely good, a lot of data and a lot of computer modeling. But what is the problem? Authors have used 3 times in the entire manuscript the word creator. They said that a creator has the creator is responsible for this kind of coordination or something. They wrote in the text 3 times the word they used creator in the entire manuscript. Now, it is an irrelevant statement. They should have said nature or evolution has caused this effect. They did not, the authors did not write this one. So church came forward, said, excellent, you have accepted you have accepted our vision. Now this is the creator that is responsible for this. But scientists said, hey, this is a relevant word because it is hurting the religious feelings and non-religious feelings, and then either way, this is not a proper method to write. And then this lot of mail in social media like WhatsApp, so many other I don't know other things as well. So they all wrote against, some in favor, some against, and the author said, scientist said, no, don't use irrelevant words. But he used, and finally the article suffered retraction. Remember, they did not do any mistake except they used 3 times. That is the problem. The same thing is sometimes when you are writing an article, don't use Allah or Mullah in that time. There are separate religious journals. There you write, but don't mix up with religion, and sometimes it causes anger among the scientific community, and also could be a problem with the church, and this case suffered. This is a bad interpretation of Scandinavia, from an article from Scandinavia. What happened was they observed a lot of microplastics in the body of fish. That is normal because the fish did not eat the microplastics directly. What probably has happened was fish ate zooplankton. Zooplankton had microplastics in its body, and then finally, when the zooplankton was digested by the fish larva, microplastics surfaced in the body. So the authors wrote, fish larva preferred microplastics to live prey. This is misinterpretation. So this caused alarming situation among the researchers. Somebody said, look, I have broken buckets, broken shoes, broken chappals, and broken plastic dishes in the house. I will give them to the fishes. Feed the fishes with my plastic from my house and give me big sized fish, a table sized fish for my eating. So they wrote in different letters. There are social media. This is not in a scientific conversation. It happened in the social media, and then each one is writing a different thing. And finally, the Uppsala University appointed a commission and then said there is some problem with the manuscript as well. The number of replicates were not proper. They did not comment on any other misinterpretation. They commented on the article was prepared hurriedly and it did not have statistical backing. Enough sampling was not done, and other variables were not taken into account. And therefore, the article was finally retracted. So when you are writing, just observe this, what Dr. Nandini also mentioned. Just straightforward your results and do not misinterpret your result or extend beyond what is not clear to you. So you could conclude this part. You could conclude this part really if you had fed the fishes with microplastics, they never eat it. So accidentally they might consume it. They is not live prey. It doesn't have any smell or any energy, so they don't eat. They reject it. But indirectly it could enter. But this is one of the problems. Now, what they have learned, scientists who suffered the biggest mistakes in their life, is that in order to make in order to develop trust in the scientific community, you must accept your mistakes immediately. Then a recent study, 2017 study, found that authors who have retracted their own article due to their own errors, they receive appreciation from their reviewers and also their colleagues and the editor-in-chiefs of many journals, stating that you are really honest, you admitted your mistake and don't commit the mistake again, but don't stop your research, start writing articles. Now, where do you consult? Much of the data that I mentioned is available free of cost for anybody. A journal called a blog. It's not a journal, it's a blog. Blog means periodically updated, doesn't have a time schedule. It's a retraction, they called Retraction Watch. It started in 2010. Is very popular among scientists and is updated periodically. And there are at least 47,000, now the number increases up to 50,000 retraction reports are there. Each one is a different reason, but most of them are fraud. Due to fraud, articles were retracted, and it's free to consult, download the full text completely. They give a lot of information. Now it is a part of many they take the information from many different journals. They don't create anything. They take from, if the article is retracted in Nature, if the editor-in-chief writes something about it, they copy that, they take that information and put in their databases. And many publishers, for example, Springer, they all are dependent on this one. How many of their own journals in different and articles in different journals are retracted and why, so that they can stop this unethical issue and proceed forward. And it's free for all of you. You can consult and download full text. Now, what I'm going to conclude now, retraction is definitely an academic dishonesty. Whether you accept it or you don't accept later on or immediately, but it is an academic dishonesty because you have done an academic crime. So be careful, avoid it for the future. This is number one. Retraction is not a simple process. It is a complex process. It doesn't overnight take place. Editor-in-chief himself cannot retract any article. If that is the case, he would have retracted all the articles as soon as he becomes editor-in-chief. That is not the case. Editor-in-chief should write to the authors, listen to their argument, and balance at the end. And whether or not to be retracted, it's dependent on the users who pointed out and the authors who counteracted and so on. And different forces act upon this, including the social media these days. Mistrust in science is developing, especially after COVID. And somebody suggested to take formalin to kill the COVID completely. Somebody said to take another one, take another one, some kind of antibiotics, but nothing functioned. So these are all mistrust is developing in social media. Social media, every time if one person receives information today and if sends on social media, it is multiplied by 1,000 times. That is the power of social media. Do not ignore this one. Even politicians are afraid of social media because their elections can be just brought down. Anyway, so this is, we should be careful not to make any mistakes, and if don't be in a great hurry to submit with great errors and grave errors that could cause problems. And retraction also is an insult to your university, to your institution, and sometimes to your country. And we all have to collectively, including the students, professors, and other stakeholders in science, to eradicate this problem. I thank you very much.
Thank you, sir. A very interesting lecture. That means right from writing to manuscript, from publication, we have to be very careful. So very interesting and eye-opening lecture. I think there may be so many questions, students, especially who are, and the faculties also who are writing the manuscript, preparing manuscripts, submitting, and actually also the reviewers also. So if anyone have any question, offline, online, they can ask.
Good afternoon, sir.
Good afternoon.
Sir, myself, Dr. Diksha Khare. Sir, I have two questions. First, we have found the retracted articles, and if one article is retracted, so after the correction, we have to publish in the same journal or any other journal.
Okay. There are two things. Sometimes the journal does not give you the opportunity to correct and resubmit. Okay. In that case, you have no other way except look for an alternative journal. The journal itself has to say that statement. Can I remove the objectionable part and then republish it? Journal said, no, we don't accept anymore. Then you have to go to the next journal. This is number one. And then why it happens and who initiates, as I mentioned, that a dozen of the stakeholders of science, anybody can detect. Sometimes you can detect your own, sometimes co-author can detect. Sometimes your institution director can detect, your head of the department can detect, your student can detect. Then you have to give a proper explanation. Though retraction appears simple, it is a very long process. It doesn't happen overnight. It happened for medical research during COVID. In 3 days time, article was published. In 3 days time, article was rejected also. I have not given many examples because it takes more time, but each example is an eye opener for the future researchers. One article was published in 3 days' time because very important to control COVID. Everybody is very happy, but the medical faculty detected great errors in this kind of conclusions and statistical violations and so on, and then they forced it to withdraw. So it is something like infantile mortality. Article appeared and disappeared.
Thank you, sir.
Thank you, sir. I just want to ask a question. Suppose some of the paper it has been submitted to me for reviewing. How can we know that the paper has been retracted? Because we don't have any data whether the paper has been retracted before or not.
This is what Dr. Andini also mentioned. You have to be careful in checking the literature. Look in the Web of Science, the same author. I have not mentioned how I review the manuscript. This is another topic. As I mentioned that we have these topics are very complex and many of them we give for my university colleagues. You have to check Web of Science, the author, the name of the author, corresponding author or the co-authors, you will find if they had any history, bad history of retraction. And compare the titles. If you don't have Web of Science, at least check Google. Google gives you some information at least.
Okay, we have to take the title also and also the name of co-authors, whether there is any retraction or like.
Yeah, that is a routine process. Dr. Nandini and I do as reviewers. We do the same thing. We handle also manuscripts for many journals. The moment the author submits, we first check the background of the author. If he has got any duplicate publications of the same work published elsewhere, and if you find it's a plagiarism, reject the manuscript or to warn the author. In the future, if you repeat, we will have to take you to task. Okay.
And also for retraction, is there any, say after 50 or 60 years, if there is duplication of data, is there some time limit or any time it can be retracted?
It can be retracted that the moment article is published or until 50 years, but there are 100 years, but there is a limitation. The authors of the retracted article must be alive because they must be consulted. Okay. It's an ethical issue, that's all.
Any other questions?
Good afternoon, sir. Sir, I have a question that being a student who is pursuing masters in zoology, what skills or areas of study should we prioritize to contribute meaningfully in the field of aquatic ecology?
That's a good question. That should be decided by your guide, by your supervisor, because I can suggest 1 dozen topics, and if you do not have facilities for these 100 topics, and how will you realize? So, as Dr. Randini mentioned, one is first your interest. Second is not the forced interest. So you develop your own interest, what your field of interest, then consult your promoter or guide, whatever you call, and then they will prune your idea so that it can fit into the laboratory objectives of the laboratory that includes the facilities, financial support, and the duration. Do not accept extremely large projects that cannot lead you anywhere because these programs are all time limited. Your scholarship is also time limited. Maybe Dr. Nandini can answer some question on that because she has got good experience with lots of students.
No, I just wanted to say that yes, what Dr. Sarma is saying is right, that you choose your project carefully with some limitation. Within the time frame, it should be done.
Okay, thank you, ma'am. Thank you, sir.
Any other participants online? Okay, she has another question.
Sir, as you said that we have to be careful while we are choosing our topic of research. But sir, apart from that, in general, what are the skills we must have?
Yeah, this is a good question. The skills available with your supervisor are the best skills. Do not borrow. There is one problem I have to tell you. In Britain, for example, you find some new techniques, some new things available. For example, if you are from botany department, in zoology department, somebody else, some of your friends, they will be doing something very interesting. But this kind of collaboration without authorization from your head of the department or dean, you should not undertake. It is an offense in the United Kingdom. Students cannot collaborate with the students of another department or another unit or another laboratory without permission from the, without authorization from the head of the division or supervisor. The reason is simple. You collaborate with some colleague from zoology department. Suppose you are from botany, you collaborate with some colleague, some friend from zoology department. Well, you can do in the night and collect the data. Excellent. But at the time of submission of the data for art, for publication or for thesis, your colleague from zoology department also will say, hey, I'm going to publish this, I'm going to use this one for my thesis. And you say, no, I want to use. At that time, the problem cannot be resolved because you have not involved initially your dean or your head of the department or rector, I don't know, whoever is there. So they cannot defend either way. So what will happen is that you lose data and you also have problems. That is why collaboration without authorization between among the students of the different laboratories is not authorized in the United Kingdom. Is prohibited. It's one of the rules for plagiarism. They consider it's also called a kind of plagiarism. I don't know why, but I think from this point of view, because at the end everybody will say that I am the author, I am the first author, I am the co-author, and so on. I'm not. You are not the author. So how will you resolve this one? So this should be done by involving. If you are a student, if you are a faculty, you are free to collaborate with anybody. Your rector will be extremely happy if you are collaborating with us, for example. So that is no problem because you are free and you don't require any degree at that stage, right? Okay.
Yes. Thank you so much, sir.
Any questions?
Hello. Sir, I want a question that if an article is from journal is for the correction is coming from us, and then after the correction, corresponding authors change the sequence of author, and we know after the publication this. Can we take the objection?
Yes, it is an ethical issue. I did not mention anything. As I mentioned, Dr. Nandini has organized a series of workshops for our colleagues. Change in the order of authorships, omitting the author, adding the author is an offense, is not acceptable unless you have a very great explanation. For example, if in the revision you need to involve a statistician because you do not know much of the statistical analysis that the very advanced statistics should be used. In that case, there is a reason that you can involve somebody, but you have to write a letter to the editor. It happened once for us for one of our articles with Maria Rosa Miracle. She was the first and corresponding author, and then Nandini became the corresponding author at the proof stage. You know why? Maria Rosa passed away. When the manuscript was under consideration, the corresponding author died. So then the editor-in-chief said somebody living should handle because we can't ask the dead person to do anything. And without corrections, article cannot be published, right? So at that time, Dr. Nandini took in charge. She's second author anyway at that time. So she responded all the questions and then she acted as a corresponding author. So it is possible, but we did not remove Maria Rosa. She was still as a first author, but with an asterisk stating that no more alive. So in that case, but you cannot change the order unless it is approved by all co-authors and the editor-in-chief should approve it. For hydrobiologia, our rule is in the journal hydrobiologia, we take the rule that if you change at the proof stage, at the revision stage, if you add one more author, remove one author, it will be treated as completely new submission. So you will have to withdraw the article completely and resubmit to the same journal with as if it is a new article. It will go to new set of reviewers.
We can take objection after publication, sir.
Yeah, if you object to the publication, that it will suffer retraction.
Okay. Okay, thank you, sir.
Sir, I would like to mention another case. Suppose we have submitted a manuscript and we have not mentioned a co-author, but after publication, what we see there is addition another co-author right from the publication department, not from us. So when it comes in a journal, there is one additional co-author which has been mentioned in the paper.
Yeah, as a co-author, you have the right to indicate that this name is illegally added. It is not a part of the team. The manuscript will suffer retraction. Immediately, it will be withdrawn.
Yeah. Okay. Thank you, sir. So it was really a very interesting session of Madam Nandini and also Dr. Sharma, both of you have given a very eye-opening how to write a manuscript, and then retraction, right from addition of co-author, then ethical issue, duplication of publication, say about even after 50 to 60 years. Then it is also very interesting that if the citation is too many, it can be also opening why there is so many. This is also a very good. Uh, Everyone should see whether the citation has gone up to 2000 or like that unusual citation, then publication fees, and one should go through whatever the article, what are the references you are going. The references is not from the retracted article, and even after that, if there is some, you have to face the consequences. So everyone, right from the authors, co-authors, reviewers, everyone should be very careful, very honest to publish your article. Thank you so
Correct.
much, sir, uh, for a
Thank you.
very, very eye-opening, and it is really very interesting, and also the honesty, it's very important for your
Correct.
research.
Correct.
Thank you.
Thank you very much. Thank you very much to all of you for a wonderful
Yes.
3 days. We enjoyed a lot.
We also enjoyed it a lot, and you were very generous even of saying that I can demonstrate the thing. And the whole session, today's session, was very important for the students, for the faculties also, not for the students, for faculty. Some of the faculties, they are reviewer, and also after, yes, and the
And
thesis.
please don't hesitate if any one of you need any little help that we can provide. Please send us your manuscripts. We are willing to revise it and give some suggestions so that it can be published easily.
Okay. So very thank you. I'm Dr. Sunita Batra from Department of Botany, one of the conveners of this workshop.
Thank you
So
so
much,
much.
Sharma sir and madam, for your so generous and helpful.
Thank you
Thank
very
you so
much.
much,
Thank
ma'am,
you
for
very much. And we will be in contact with Dr. Das.
yes, ma'am.
Sure,
Yes.
sure, sure.
Yes.
Thank
Sure.
you very much, sir
Thank
and ma'am,
you.
for your
Thank you
support.
very much. Thank you.
Thank you
Thank
very much.
you. All
So
the best to all of you. Thank you
Yeah,
very
thank you
much.
very much. Thank
you
you very
have
much.
done a research with a simple microscope and a small piece workplace. So anyone can start your research with a microscope, with a good microscope and space, and you go up to any level.
Exactly. Exactly. That
It's
is
all.
correctly. That is very correct.
Yes.
Thank you very, very much.
Okay. Thank you so much. We had really enjoyed a lot all 3 days.
Bye bye. Bye bye to all of you. All the best. Thank you.
Thank you. Thank you. Thank you so much.
Bye bye.
Thank you. Bye bye.
Now we have a lunch session, and we are going to meet
Recording stopped.
A very good afternoon to everyone. And thank you. Moving ahead in the session, we had our next guest
Recording
speaker,
in progress.
Dr. Sadhna Jaiswal, Madam. It's my great pleasure to give a brief introduction to our guest speaker. Jaiswal, Madam, did her graduation in 1995 from Robertson Science College, Jabalpur. She did MSc in microbiology in 1997 from Rani Durgavati University, Jabalpur, and PhD in microbiology in 2004 from Rani Durgavati University, Jabalpur. And she has published 11 research papers in various reputed journals and has written 7 chapters. Now, I would like to invite Dr. Sadhna Jaiswal, Madam, for her lecture. Please, ma'am. Sadhna Jaiswal, Madam, please.
Hello. A very good afternoon to all of you. Kanungo sir, Patra madam, Das madam, Gupta madam, सतीश सर, सभी को बहुत बहुत धन्यवाद कि मुझे आज आप लोगों के सामने कुछ कहने का अवसर दिया गया है। मैं कोशिश करूंगी कि जो भी आप लोगों की जो भी शंकाएं हैं उनको या संदेह है उनको दूर करने का रिलेटेड टू द collection, isolation and identification of bacteria from water and microbiological examination of water. तो बच्चे लोग जैसा आप सभी लोग जानते हैं, water is the one of the most Water is one of the most important elements for all forms of life and basic necessity for survival. जैसे जल ही जीवन है, आप सभी लोग जानते हैं कि जल के बिना जीवन जो है उसकी संभावना बहुत ही कठिन है. Safe drinking water is a fundamental human requirement, है ना. जो safe जो drinking water है वो human being के लिए एक fundamental need है, क्योंकि यदि अगर वाटर जो है वो कंटामिनेटेड होगा किसी अपॉर्चुनिस्टिक पैथोजन से, तो इट मे कॉज हेल्थ इम्प्लीकेशंस फॉर द कंज्यूमर्स. जो भी उसको कंज्यूम करते हैं उसमें तरह तरह के जो हेल्थ इम्प्लीकेशंस हैं वो हो सकते हैं. ह्यूमन हेल्थ शुड देयरफॉर बी प्रोटेक्टेड बाय प्रिवेंटिंग माइक्रोबियल कंटामिनेशन ऑफ वाटर. तो जो ह्यूमन बीइंग हैं उनके बहुत सारे जो डिजीज हैं जो कि वाटर बॉर्न डिजीज हैं उनको हम प्रिवेंट कर सकते हैं यदि हम वाटर के कंटामिनेशन को रोक पाएं, या यदि वाटर अगर कोई कंटामिनेटेड है और उसको हम पता लगा पाएं समय पर और उसके कंजम्पशन पे हम उसकी प्रॉपर मॉनिटरिंग कर पाएं. नेक्स्ट प्लीज. तो जो ऑब्जेक्टिव्स हैं आज के जो डिस्कशन का, टू अंडरस्टैंड द इंस्ट्रूमेंटेशन यूज्ड इन माइक्रोबायोलॉजिकल एग्जामिनेशन ऑफ वाटर. फोकस ऑन टेक्निक्स फॉर कौन कौन से इसमें हम टेक्निक यूज करते हैं माइक्रोबायोलॉजिकल एग्जामिनेशन ऑफ वाटर के लिए. तो उसमें आता है आपका कलेक्शन ऑफ प्लैंक्टोनिक बैक्टीरिया. सबसे पहले बात आता है कि जो भी हम वाटर बॉडी पे काम करना चाहते हैं या जिसकी हम मॉनिटरिंग करना चाहते हैं वहां पे हम किस तरह से सैंपल को कलेक्ट करें या कलेक्शन के कौन कौन से मेथड्स हैं. देन द आइसोलेशन एंड आइडेंटिफिकेशन प्रोसेस. फिर उसको हम किस तरह से वहां से हम ऑर्गेनिज्म को आइसोलेट करेंगे और कैसे उसको हम आइडेंटिफाई करेंगे। तो आज का जो मैंने जो टॉपिक लिया है उसमें मैंने बेसिकली जो है बैक्टीरिया को ही फोकस किया है कि बैक्टीरिया का आइसोलेशन किस तरह से किया जाता है। फिर उसके बाद उसके प्रिजर्वेशन मेथड्स, अगर हम आइसोलेट कर लेते हैं तो उसको कैसे हम प्रिजर्व करके रख सकते हैं ताकि हम उसकी फर्दर स्टडी कर सकें। देन नेक्स्ट टॉपिक है माइक्रोबायोलॉजिकल एग्जामिनेशन ऑफ पोर्टेबिलिटी ऑफ वाटर। जो पोर्टेबल वाटर है, जो ड्रिंकिंग वाटर है, उसका हम माइक्रोबायोलॉजिकल कैसे एग्जामिनेशन करेंगे और कैसे हम यह पता करेंगे कि ये जो वाटर है वह पीने लायक है या नहीं है। नेक्स्ट प्लीज। अब है इंपॉर्टेंस ऑफ प्लैंक्टोनिक बैक्टीरिया स्टडी। इसकी हम स्टडी क्यों कर रहे हैं? जैसे कि पहले मैंने कहा कि जो पैथोजेनिक ऑर्गेनिजम्स हैं उसके लिए, इसके अलावा भी कुछ इसके इन्वायरमेंटल सिग्निफिकेंसेस हैं, लाइक इंडिकेटर्स ऑफ द वाटर क्वालिटी। वाटर क्वालिटी के जो कुछ इंडिकेटर्स हैं, इंडिकेटर ऑर्गेनिजम्स होते हैं जो हमको वाटर की क्वालिटी को प्रदर्शित करते हैं कि ये किस तरह के वाटर है। रोल इन न्यूट्रिएंट साइक्लिंग एंड इकोसिस्टम बैलेंस। हमारा जो एक्वेटिक इकोसिस्टम है उसके बैलेंस के लिए और वहाँ पे न्यूट्रिएंट साइक्लिंग के लिए इनका माइक्रोबायोलॉजिकल स्टडी करना आवश्यक होता है। देन इसके कुछ हेल्थ इम्प्लीकेशंस जो हैं उसकी स्टडी के लिए भी चाहिए। डिटेक्शन ऑफ पैथोजेनिक बैक्टीरिया, किसी वाटर बॉडी में अगर कोई पैथोजेनिक बैक्टीरिया है या नहीं है उसको डिटेक्ट करना, और यदि है तो उसको कैसे हम हटा सकते हैं या किस तरह से हम उसकी मॉनिटरिंग कर सकते हैं। और मॉनिटरिंग ऑफ द ड्रिंकिंग वाटर सेफ्टी, ये जो है हर एक जगह जहाँ भी वाटर प्यूरिफिकेशन प्लांट्स होते हैं वहाँ पे इसकी मॉनिटरिंग की जाती है कि किस तरह से वाटर बॉडी को मॉनिटर किया जाए। तो सबसे पहले जैसे कि बात हुई कि कलेक्शन के लिए हम कौन कौन से इंस्ट्रूमेंट्स यूज करते हैं या सैंपल को हम कलेक्शन कैसे करें या कैसे ढंग से हम वाटर सैंपल कलेक्ट कर सकते हैं। तो वाटर सैंपलिंग जो बॉटल्स होते हैं जो कि स्टेराइल एयर टाइट कंटेनर्स मेड ऑफ ग्लास और प्लास्टिक्स, उसमें हम वाटर सैंपल को कलेक्ट करते हैं। ये कब होगा? जिस समय अगर आपको सरफेस वाटर सैंपल को कलेक्शन करना है तो उस समय हम इस तरह के ग्लास बॉटल्स का उपयोग करते हैं। यदि आपको प्लैंक्टन्स का कलेक्शन करना है, जैसे कि मान लीजिए साइनोबैक्टीरिया का करना है या इसके अलावा जू प्लैंक्टन्स वगैरह का कलेक्शन करना है, तो उसके लिए यहाँ पे फिगर भी दिया हुआ है जिसको अपन कहते हैं प्लैंक्टन नेट्स। ये प्लैंक्टन नेट्स के द्वारा हम उसका कलेक्शन करते हैं। देन है आपका वन डाउन बॉटल्स। यदि हमको किसी एक निश्चित डेप्थ से वाटर कलेक्शन करना है कि बॉटम से करना है या इतने मीटर की गहराई से करना है, तो उस समय हम वन डाउन बॉटल्स का उपयोग करते हैं, जो कि इसमें भी एक फिगर या एक इमेज दिया हुआ है। देन है कलेक्शन, है ना। फिर है कलेक्शन टेक्निक्स सरफेस वाटर सैंपलिंग के लिए, जैसे कि यूज स्टेराइल बॉटल्स डायरेक्टली डिप्ड इनटू द वाटर। सीधे हम जो है स्टेराइल बॉटल्स को पानी में डुबा करके, जैसे कि नॉर्मल हम लोग वाटर कलेक्ट करते हैं उसी तरह से इसको कलेक्शन किया जाता है। अगर डेप्थ सैंपलिंग है, जैसे कि मैंने कहा कि वन डाउन बॉटल्स का उपयोग किया जाता है, उसमें एक वायर लगा होता है जिससे कि हम उसकी डेप्थ को मेजर कर सकते हैं। फिर उसके बाद है आपका प्लैंक्टन टॉइन, जिसमें कि नेट का उपयोग करते हैं और प्लैंक्टन्स का कलेक्शन किया जाता है। नेक्स्ट कीजिए। फिर अपना आ जाते हैं आइसोलेशन में कौन कौन से, एक बार हमने सैंपल कलेक्ट कर लिया, सैंपल कलेक्ट करने के बाद जो सैंपलिंग साइट है वहां से अगर हम उसको लेबोरेटरी में लाते हैं तो उसको अपन कहते हैं ट्रांसपोर्टेशन। वो यहाँ पे थोड़ा स्केप हो गया है कि किस तरह से अगर हमने सैंपल कलेक्ट किया पर उसका ट्रांसपोर्टेशन कैसे करना है। सैंपल कलेक्ट करने के बाद उसको हम क्या करते हैं, आइस में लेकर के आते हैं, और ताकि उसमें और फर्दर ग्रोथ ना हो या उसमें अगर कोई तरह के ऑर्गेनिजम्स हैं उनका डिस्ट्रक्शन ना हो, तो उसके लिए हम उसको 4 डिग्री सेंटीग्रेड पर लेकर के हम लेबोरेटरी तक ट्रांसपोर्ट करते हैं और उसके बाद उसकी फर्दर स्टडी करते हैं। जब तक अगर आप तुरंत सैंपल को, वैसे तुरंत करना चाहिए विदिन 1 आवर, लेकिन अगर नहीं कर पाते हैं, मान लीजिए आपको 24 आवर्स लगते हैं, तो उसको हमको रेफ्रिजरेटर में उसको स्टोर करके रखना चाहिए ताकि उसके पैरामीटर्स जो है वो चेंज नहीं हो। आइसोलेशन के जो इंस्ट्रूमेंट्स हैं और कौन कौन से जो मीडिया हैं उनका उपयोग कैसे हम करते हैं या कब किस तरह से हम कौन से मीडिया लेंगे या कौन कौन से इंस्ट्रूमेंट्स हैं जिनका हम यूज करेंगे ताकि हम उसमें जो प्लैंक्टोनिक फार्म्स हैं, जो बैक्टीरिया हैं, उनका हम प्रॉपर आइसोलेशन कर पाए। तो उसके लिए सबसे पहले जो रिक्वायरमेंट है वो है आपके स्टेराइल पेट्री डिशेस। जो पेट्री डिशेस उसमें हमको क्योंकि कल्चर करना रहता है तो वो कैसे होना चाहिए, स्टेरलाइज होना चाहिए। और स्टेरलाइज करने के लिए हमारे पास 2 मेथड है। एक तो हम उसको ऑटोक्लेविंग कर सकते हैं जिसमें कि स्टीम अंडर प्रेशर से उसका स्टेरलाइजेशन होता है। इसके अलावा आप ड्राई, जो आपका हॉट एयर ओवन है, उसमें भी हम एक टेम्परेचर कंट्रोल यूनिट होता है जिससे कि हम उसको स्टेरलाइजेशन कर सकते हैं। तो स्टेरलाइज पेट्री डिशेस उसमें हमको चाहिए। मैंने सेंट्रीफ्यूज फॉर द सेडिमेंट, कंसंट्रेशन, यदि हमको सेडिमेंट का सैंपल लेना है या बहुत एक डीप लेवल का लेना है सैंपल, तो उसके लिए हमारे पास सेंट्रीफ्यूज होने चाहिए ताकि हम उसको प्रॉपर सेंट्रीफ्यूगेशन कर पाएं। और जो जिस लेवल का आपको वाटर चाहिए, आपको अगर सुपरनेटेड का करना है या ऊपर का करना है तो कर ले सकते हैं, या फिर आपको सेडिमेंट का करना है तो उसका जो नीचे जो पैलेट आता है उसको हम उपयोग करते हैं फॉर द आइसोलेशन पर्पस। देन लेमिनार एयर फ्लो हुड चाहिए, क्योंकि एसेप्टिक कंडीशन हमको वहां पे चाहिए आइसोलेशन के लिए। इसलिए क्योंकि यदि हम बाहर अगर लेमिनार एयर फ्लो के बाहर ही अगर हम आइसोलेशन प्रोसेस करें या उसके बाहर ही यदि किसी तरह के हम प्रोसेसिंग करेंगे, तो क्योंकि इन्वायरमेंट में जो ऑर्गेनिजम्स है वो ऐसे ही प्रेजेंट है, एयर में भी हैं, वाटर में भी हैं, सॉइल में है, जैसे कि आप लोग सभी जानते हैं कि माइक्रोब्स जो है वो दिखते नहीं है लेकिन वो प्रेजेंट हर जगह है। तो अगर हम उसको बाहर ही करेंगे तो क्या होगा, उसमें ठीक से मतलब जो हमको चाहिए वो ना हो करके कि एनवायरनमेंट के जो अदर ऑर्गेनिजम्स हैं वो ग्रो करने लगेंगे। इसलिए हमको एसेप्टिक कंडीशंस चाहिए और उसके लिए हमको लेमिनार एयर फ्लो हुड की आवश्यकता होती है। देन इंक्यूबेटर टू मेंटेन द प्रॉपर टेम्परेचर। एक बार हमने प्रोसेसिंग कर लिया पेट्री डिश में, तो उसको हमको इंक्यूबेट करना पड़ता है, एक ऑप्टिमम टेम्परेचर प्रोवाइड करना पड़ता है, जो हमारा डिजायर्ड ऑर्गेनिज्म है जो हमको चाहिए उसके अकॉर्डिंग जो है हमारे पास इंक्यूबेटर्स होने चाहिए। क्योंकि जो इन्वायरमेंट का जो क्लाइमेटिक जो कंडीशन है वहां पे जो टेम्परेचर है उसमें वो ग्रो करेंगे कि नहीं, है ना। तो अगर वो उनके प्रॉपर टेम्परेचर है तो ग्रो करेंगे, लेकिन अगर नहीं है तो उसके लिए हमको क्या लगेगा, इंक्यूबेटर लगेगा। जैसे अगर आपको थर्मोफाइल्स आइसोलेट करने हैं तो हाई टेम्परेचर चाहिए, अगर आपको साइक्रोफाइल्स करना है तो लो टेम्परेचर चाहिए, यदि आपको मीडियम सामान्य मीजोफाइल्स करना है तो 37 डिग्री चाहिए, और हर समय 37 डिग्री अवेलेबल नहीं है। तो इसलिए वहां पे हमको इंक्यूबेटर्स की जरूरत होती है। इसके अलावा और भी जैसे कि मैंने कहा ऑटोक्लेव्स और इस तरह के जो इंस्ट्रूमेंट्स हैं, हार्ट एयर ओवन, इनकी भी हमको आवश्यकता होती है फॉर द आइसोलेशन ऑफ द ऑर्गेनिजम्स और माइक्रो ऑर्गेनिजम्स। फिर उसके अलावा हमको उसको एक मीडिया प्रोवाइड करना पड़ता है। मीडिया का मतलब होता है जैसे कि हम लोग के लिए जो फूड होता है ना, हम लोग जो खाना खाते हैं उससे हमको एनर्जी मिलता है, ऐसे ही जो ऑर्गेनिजम्स हैं उनको भी एक फूड चाहिए। तो उनको किस तरह का फूड चाहिए उसके अकॉर्डिंग हम उनको मीडिया प्रिपेयर करते हैं, और उनको कहा जाता है कल्चर मीडिया, जिससे कि उनको एक प्रॉपर हर चीज का सोर्स मिलना चाहिए, जैसे मिनरल का भी सोर्स हो उनके पास, और कार्बन सोर्स होना चाहिए, नाइट्रोजन सोर्स होना चाहिए, जो कि उनके रिक्वायरमेंट्स को फुलफिल करे और तभी वो ग्रो करेंगे। तो इसके लिए हमको न्यूट्रिएंट मीडिया, मतलब जो भी आपका कल्चर मीडिया है उसकी रिक्वायरमेंट होती है। जनरली सामान्य आइसोलेशन के लिए बैक्टीरिया के लिए हम लोग न्यूट्रिएंट अगार मीडिया का उपयोग करते हैं, और फंगस के आइसोलेशन के लिए पोटैटो डेक्सट्रोज अगार मीडिया या सेवरॉड अगार मीडिया का उपयोग भी किया जाता है। इसके अलावा कुछ स्पेसिफिक जो बैक्टीरियल ग्रुप्स हैं उसके लिए सेलेक्टिव मीडिया, जैसे कि कोलीफॉर्म्स को आइसोलेट करना है तो उसके लिए हमको ईएमबी अगार मीडिया चाहिए। इसके अलावा बहुत सारे और भी सेलेक्टिव मीडिया, जैसे लेक्टोज फर्मेंटर्स हैं तो उनके लिए अलग तरह की मीडिया चाहिए। तो इस तरह से अलग अलग जिस तरह आपका क्या पर्पज है, आप किस तरह का ऑर्गेनिज्म आइसोलेट करना चाहते हैं उसके अकॉर्डिंग आपको मीडिया का सिलेक्शन करना होता है। नेक्स्ट प्लीज। अब आ जाते हैं हम लोग, एक बार मीडिया सेलेक्ट हो गया, मीडिया भी हमारा कैसा होगा, स्टेरलाइज कर लेते हैं, उसको भी ऑटोक्लेव करते हैं, और ऑटोक्लेव करने के बाद उसको हम लोग जैसे कि इसमें फिगर में दिख रहा है आपको कि एक पेटी प्लेट में हम क्या करते हैं कि मीडिया को पोर करते हैं, स्टेरलाइज मीडिया को। पेटी प्लेट भी हमारा स्टेरलाइज है और मीडिया भी स्टेरलाइज होना चाहिए, और ये सब जितना भी हम करते हैं वो एसेप्टिक कंडीशन में अंडर द लेमिनार एयर फ्लो हुड में करते हैं। और इसके साथ साथ हमको उसमें फ्लेम की भी जरूरत होती है, या बुनसन बर्नर भी वहाँ पे आवश्यक होता है। बहुत ही स्मॉल अमाउंट ऑफ द सैंपल जो है उसको लेकर के हम जो पेटी प्लेट है जिसमें कि स्टेरलाइज मीडिया जो है वो सॉलिडिफाइड है, उसमें हम बहुत थोड़ा अमाउंट ऑफ सैंपल लेते हैं, वाटर सैंपल, और उसको स्मूथली पूरे सरफेस पे हम स्प्रेड कर देते हैं, और इस टेक्निक को हम कहते हैं स्प्रेड प्लेट टेक्निक। स्प्रेड करने के बाद उसको क्या किया, और बाय यूजिंग द ग्लास स्प्रेडर आते हैं, प्लास्टिक के भी स्प्रेडर्स आते हैं, तो इनसे हम उसको क्या करते हैं स्प्रेड कर देते हैं ताकि उसको इवनली उसमें स्प्रेड हो सके। और उसके बाद फिर उसको हम इंक्यूबेट कर देते हैं फॉर द प्रॉपर टेम्परेचर, और उसको वेट करते हैं 24 टू 48 आवर्स। नॉर्मली जो बैक्टीरिया की ग्रोथ जो है 24 आवर्स से 48 आवर्स में हो ही जाता है, लेकिन कुछ बैक्टीरिया होते हैं जो स्लो ग्रोइंग होते हैं, उनके लिए हमको थोड़ा सा इंक्यूबेशन जो पीरियड है उसको हमको इलांगेट करना पड़ता है, या ज्यादा दिन भी देना पड़ सकता है। फिर उसमें देखते हैं कि जो कॉलोनी डेवलप होती है, मतलब जो हर एक जो हम ये सोचते हैं कि एक एक जो सेल है ना वो एक सिंगल कॉलोनी डेवलप कर रहा है, तो हर एक जो सेल है जितनी कॉलोनी है वो सबको हम क्या मानते हैं, प्योर कल्चर मानते हैं, क्योंकि एक एक कॉलोनी एक प्योर कल्चर है, क्योंकि एक सिंगल सेल से वो डेवलप हुआ है। नेक्स्ट करो। दूसरा जो मेथड है वो है आपका स्ट्रीक प्लेट मेथड। जनरली इसका जो उपयोग है वो प्यूरिफिकेशन के लिए किया जाता है स्ट्रीक प्लेट मेथड के ऊपर। इसमें हम क्या करते हैं कि जो ऑलरेडी जो आइसोलेटेड कॉलोनीज हैं, जैसे कि हमने जो स्प्रेड प्लेट में जो कॉलोनीज जो डेवलप हुई हैं, उन कॉलोनीज में से जिस कॉलोनी को हमको जिसमें और उसको हमको प्यूरिफाई करना है, तो उसको लेकर के हम पिक करते हैं विद द हेल्प ऑफ इनोकुलेटिंग लूप, और उसको हम क्या करते हैं इस तरह से, जैसे कि उसमें हमने पेट्री प्लेट यूज किया था जिसमें कि सॉलिडिफाइड अगार मीडिया था, ऐसे ही पेट्री प्लेट में जो कि स्टेरलाइज होते हैं और सॉलिडिफाइड अगार मीडिया के साथ में होते हैं, उसके ऊपर हम क्या करते हैं उसमें स्ट्रीकिंग करते हैं। स्ट्रीकिंग के कई पैटर्न हो सकते हैं, जैसे कि जिगजैग पैटर्न होता है, सर्कुलर पैटर्न होता है, क्वाड्रेटिक पैटर्न होता है, अलग अलग उसके पैटर्न हो सकते हैं स्ट्रीक करने का। तो एक्चुअली होता क्या है कि जहां से हम स्ट्रीकिंग शुरू करते हैं तो वहां पे क्या होता है, डेंस कॉलोनीज आती है, क्योंकि बहुत सारे ऑर्गेनिज्म थे वहां पे। लेकिन जैसे जैसे हम स्ट्रीकिंग को आगे बढ़ाते जाते हैं, जैसे देखिए उसमें जिग जैक है, तो जहाँ शुरुआत होगी वहां पे मोटी कॉलोनीज डेवलप होंगी, और जहाँ पे हम एंड करेंगे, जब वहां पे आखिरी करेंगे, तो वहां पे हमको सिंगल सिंगल जो कॉलोनीज हैं वो आपको दिख जाएंगी। इसको मैं आपको लैब में भी दिखा दूंगी कि किस तरह से स्ट्रीकिंग में आखिरी में जो है सिंगल कॉलोनीज डेवलप हुई आपको दिखती हैं। तो जैसे ही वो सिंगल कॉलोनीज मिलेंगी तो मतलब हमारा पर्पस सॉल्व हो जाता है कि दे आर द प्योर कल्चर। वो हमारा प्योर कल्चर होता है जिसको कि हम उठा करके नए मीडिया में ट्रांसफर कर सकते हैं, और उससे हम उसका प्यूरिफिकेशन आगे कर सकते हैं, और उसको हम मेंटेन कर सकते हैं, उसकी फर्दर स्टडी कर सकते हैं। नेक्स्ट। फिर इसके अलावा है आपका एनरिचमेंट कल्चर। अब एनरिचमेंट कल्चर क्या होगा, जैसे कि स्प्रेड प्लेट हो गया, स्ट्रिक प्लेट हो गया, इसके बाद होता है एनरिचमेंट का मतलब है कि जैसे किसी स्पेसिफिक टाइप का ऑर्गेनिज्म को हमको आइसोलेट करना है, तो उसके लिए हमको एनरिचमेंट कल्चर देना पड़ता है। और एनरिचमेंट हमको या तो हम मीडिया में किसी प्रकार का कोई चेंज कर दें जिससे कि किसी एक तरह के ऑर्गेनिज्म की ग्रोथ को सपोर्ट करे, और दूसरे तरह के ऑर्गेनिज्म की जो ग्रोथ है उसको वह इनहिबिट करे या उसको सपोर्ट ना करे। तो एक तरह के ऑर्गेनिज्म की ग्रोथ को सपोर्ट करेगा तो क्या होगा कि उसकी कॉलोनी तो डेवलप होगी, लेकिन जिसकी ग्रोथ को सपोर्ट नहीं करेगा उसकी कॉलोनी डेवलप नहीं होगी। तो इस तरह से हमको जो हमको चाहिए वो ऑर्गेनिजम्स वहाँ पे आ जाते हैं। तो इसके लिए हम लोग जो मीडिया है उसमें कुछ परिवर्तन कर देते हैं, जैसे कि मान लीजिए अगर हमको ग्राम पॉजिटिव बैक्टीरिया ही ग्राम नेगेटिव बैक्टीरिया की ग्रोथ करनी है, तो ऐसे हम उसमें ऐसे डाई का उपयोग कर लेते हैं जिसमें ग्राम पॉजिटिव बैक्टीरिया उसमें उगेंगे ही नहीं। तो इस तरह से हमको एक तरह के ऑर्गेनिज्म जो है वो प्राप्त हो जाते हैं। इसके अलावा जो है क्लाइमेटिक चेंजेस के द्वारा भी हम एनरिचमेंट कर सकते हैं। मतलब जैसे क्लाइमेटिक का मतलब जैसे उनका जो रिक्वायरमेंट है, लाइक टेम्परेचर रिक्वायरमेंट है या पीएच रिक्वायरमेंट है, उनमें भी अल्टरेशन करके उनमें भी अगर हम बदलाव करते हैं तो उससे भी हम मीडिया को एनरिच कर सकते हैं, उसको एनरिच कर सकते हैं और उस तरह के ऑर्गेनिजम्स को हम आइसोलेट कर सकते हैं। नेक्स्ट प्लीज। तो इस तरह से हमारे जो कल्चर्स हैं वो क्या हो जाते हैं, आइसोलेट हो जाते हैं और हमको प्योर कल्चर मिल जाता है। अब बात आती है उसके आइडेंटिफिकेशन की। एक बार हमने प्योर कल्चर प्राप्त कर लिया तो हमें पता नहीं है कि वो क्या है करके, है ना। तो उसके लिए हमको क्या करना होगा, उसका एक प्रोबेबल आइडेंटिफिकेशन ही होता है। अगर हम बायोकेमिकल टेस्ट और मार्फोलॉजिकल देखें तो, और उसका अगर हमको कंफर्म आइडेंटिफिकेशन करना है तो उसके लिए हमको सीक्वेंसिंग में जाना पड़ता है, मॉलिक्यूलर कैरेक्टराइजेशन उसकी करनी होती है। तो आइडेंटिफिकेशन के लिए क्या क्या हमको चाहिए, सबसे पहले तो हमको माइक्रोस्कोप चाहिए, जिसमें कि आपको ब्राइट फील्ड माइक्रोस्कोप जो जनरल आप लोग नॉर्मल जो यूज करते हैं उसका उपयोग कर सकते हैं। इसके अलावा जो है आपको फ्लोरोसेंट माइक्रोस्कोप चाहिए यदि हम उसकी एक और प्रॉपर आगे की स्टैंडिंग करते हैं तो। फिर उसके बाद है आपको स्पेक्ट्रोफोटोमीटर, यदि हम उसको ग्रोथ मेजरमेंट करना चाहते हैं तो उसके लिए स्पेक्ट्रोफोटोमीटर चाहिए। फिर है आपका पीसीआर मशीन चाहिए, अगर आपको मॉलिक्यूलर कैरेक्टराइजेशन करना है, जीन लेवल में उसमें जाकर पता करना है, तो उसके लिए हमको पीसीआर मशीन की आवश्यकता होती है। नेक्स्ट प्लीज। तो सबसे पहले मैं आपको स्टेनिंग मेथड्स बताऊंगी। तो स्टेनिंग हम लोग क्या क्या आवश्यक होता है बैक्टीरियल आइडेंटिफिकेशन के लिए, वो है हमारे पहले तो है आपका ग्राम स्टेनिंग जो कि सबसे फंडामेंटल स्टेनिंग है। फिर उसके बाद है आपका एंडोस्पोर स्टेनिंग है, देन कैप्सूल स्टेनिंग है और फ्लैजिला स्टेनिंग है। ये हर तरह के जो स्टेनिंग है दे आर कॉल्ड द डिफरेंशियल स्टेनिंग टेक्निक्स। डिफरेंशियल का मतलब होता है डिफरेंशिएट, मतलब विभेदित करना, मतलब एक से दूसरे को पहचानना, वो होता है आपका डिफरेंशियल। तो डिफरेंशियल इसीलिए इसका नाम रखा गया है डिफरेंशियल स्टेनिंग, क्योंकि ये दो तरह मतलब एक साथ अगर दो तरह के ऑर्गेनिज्म है तो दोनों को वो अलग अलग तरह के दिखाएगा ताकि आप उसको पहचान जाओगे कि ये चीज है, ये दूसरी चीज है। तो इसीलिए इनको अपन डिफरेंशियल स्टेनिंग कहते हैं। इसके अलावा बायोकेमिकल टेस्ट होते हैं, सीरीज ऑफ बायोकेमिकल टेस्ट आर देयर। बहुत सारे बायोकेमिकल टेस्ट है जिसमें कि कुछ मैं यहाँ पे मेंशन मैंने किया हुआ है जो कि काफी जरूरी होते हैं, लाइक द इम्विक टेस्ट है, कैटालेज टेस्ट, ऑक्सीडेज, अमाइलेज, लाइपेज, यूरिएज, स्ट्रेस प्रोडक्शन and the sugar fermentation test. These are the basic tests for the biochemical test for the बैक्टीरियल आइडेंटिफिकेशन। फिर उसके बाद मॉलिक्यूलर टेक्निक्स, जैसे कि मैंने कहा कि पीसीआर से हम उसकी 16s राइबोसोमल आरएनए की सीक्वेंसिंग करा लेते हैं, जिससे कि हमको काफी ज्यादा हम उसके जीनस और स्पीसीज लेवल तक पहुंच पाते हैं। तो पहला जो है वो है आपका ग्राम स्टेनिंग। शायद आप में से कुछ लोगों ने किया भी होगा ग्राम स्टेनिंग, है ना। तो ग्राम स्टेनिंग से हमको, मैं ज्यादा इसमें नहीं जाऊंगी। ग्राम स्टेनिंग में हमको क्या पता चलता है कि जो बैक्टीरिया है, एक्चुअली जो टोटल जो बैक्टीरियल जो वर्ल्ड है उसको दो बड़े ब्रॉड कैटेगरीज में डिवाइड किया गया, ग्राम पॉजिटिव एंड ग्राम नेगेटिव, ऑन द बेसिस ऑफ देयर सेल वॉल स्ट्रक्चर। ये सभी लोग को पता था, है ना। तो जो ग्राम स्टेनिंग है यही बताता है कि कौन से ऑर्गेनिज्म ग्राम पॉजिटिव है और कौन से ऑर्गेनिज्म ग्राम नेगेटिव है। तो ये कैटेगराइज करता है दो अलग अलग तरह के सेल वॉल वाले बैक्टीरिया को, है ना। तो इस तरह से इसका एक फ्लो डायग्राम है। मुझे लगता है ये सबको पता है, तो मैं आगे चलूं। नेक्स्ट प्लीज। ग्राम स्टेनिंग से हमको ग्राम पॉजिटिव और ग्राम नेगेटिव का तो पता चलता है, इसके अलावा उसमें और भी चीजें हम देख सकते हैं, जैसे कि शेप ऑफ द सेल, सेल का जो है शेप कैसा है, रॉड है कि कोकस है। इसके अलावा उसका अरेंजमेंट भी देख सकते हैं कि उसका अरेंजमेंट कैसा है, मतलब वो स्टेफाइलोकोकस है कि स्ट्रेप्टोकोकस है कि वो सिंगल सिंगल मोनोकोकस है, किस तरह के सेल्स है, उसको भी हम देखने के लिए ग्राम स्टेनिंग टेक्निक का उपयोग करते हैं। फिर है आपका एंडोस्पोर स्टेनिंग। उसके बाद आगे अगर हमको पता चल गया कि ये ग्राम पॉजिटिव है और ग्राम नेगेटिव है, तो हम और नेक्स्ट स्टेप में जाते हैं कि ये क्या स्पोर फार्मर है या स्पोर फार्मर नहीं है। जैसे कि आप लोग को पता ही होगा कि सभी तरह के बैक्टीरिया स्पोर का फॉर्मेशन नहीं करते हैं। कुछ ऑर्गेनिजम्स हैं जो स्पोर फार्मर्स हैं, जबकि बहुत सारे ऐसे हैं जो कि नॉन स्पोर फार्मर्स होते हैं। तो स्पोर फार्मर्स के लिए या एंडोस्पोर की जो स्टेनिंग है उसके लिए हम लोग यूज करते हैं मेलाकाइट ग्रीन, एक डाई है मेलाकाइट ग्रीन, इसको हम लोग लेते हैं, है ना। इससे हम स्टेनिंग करते हैं। उसके लिए सबसे पहले बैक्टीरियल स्मीयर प्रिपेयर किया जाता है, जैसे कि आपको ग्राम स्टेनिंग में स्मीयर प्रिपेयर करना है, उसी तरह से इसमें भी स्मीयर का प्रिपरेशन होता है। फिर उसके बाद उसमें हम मेलाकाइट ग्रीन जो डाई है उसको अप्लाई करते हैं। अप्लाई करके उसके बाद उसको थोड़ा सा गर्म करते हैं। गर्म करने पर ये जो मेलाकाइट ग्रीन है उसके सेल के अंदर वो पहुंच जाता है और एंडोस्पोर को स्टेन करता है। फिर उसके बाद हम उसमें नेक्स्ट उसका स्टेप होता है वॉशिंग, जिसमें कि हम उसमें वाटर से उसको हम वॉश कर देते हैं। और उसके बाद जो है उसको ड्राई जब हो जाती है स्लाइड, तो उसको हम माइक्रोस्कोप में ऑब्जर्व कर सकते हैं, जिसमें कि हमको एंडोस्पोर्स जो है वो कलर्ड एंडोस्पोर्स आपको। फिर उसके बाद काउंटर स्टेन है, जिसमें कि हम सेफ्रेनिन का उपयोग करते हैं या इओसिन का उपयोग भी आप कर सकते हो। कोई भी दूसरा जो डाई है जो कि दूसरे कलर का होगा उसका हम उसमें यूज करते हैं। तो इस तरह से अदर जो कलर वाले जो हैं, तो इस प्रकार से हमको जो स्पोर हैं, एंडोस्पोर हैं, वो हमको ग्रीन कलर के दिखाई देते हैं। जो अगर स्पोर फार्मर्स हैं तो उसमें आपको एंडोस्पोर दिखेगा, अगर नॉन स्पोर फार्मर्स हैं तो उसमें आपको सारे सेल्स पिंक कलर के या सेफ्रेनिन के कलर के दिखाई देंगे। हम लोग कैप्सूल स्टेनिंग। कैप्सूल स्टेनिंग जो है एक नेगेटिव स्टेनिंग टेक्निक है, क्योंकि कैप्सूल एक ऐसा लेयर होता है जो सभी बैक्टीरिया में नहीं होता है। कुछ कैप्सुलेटेड होते हैं, कुछ नॉन कैप्सुलेटेड होते हैं। तो कैप्सूल जो है कहाँ होता है, सेल वॉल के ऊपर होता है ना भाई। और एक ऐसा लेयर होता है जिसमें कि डाई जो है अंदर प्रवेश नहीं कर पाता है। तो इसलिए क्या करते हैं वहां पे, जो इसको अपन करते हैं नेगेटिव स्टेनिंग। नेगेटिव स्टेनिंग का मतलब होता है कि हम बैकग्राउंड को स्टेन कर देते हैं और उसके बाद हम देखते हैं उसको कहाँ पर, माइक्रोस्कोप में, है ना भाई। तो स्मीयर इसमें भी इसी तरह से प्रिपेयर करना है। स्मीयर प्रिपेयर करने के बाद इसमें हम ऐसा डाई उपयोग करते हैं जिसमें कि हम बैकग्राउंड को खाली जो है वो कलर करें। इसके जैसे कि इंडिया इंक वगैरह का उपयोग किया जाता है। और इस तरह से देखिए जो सेल्स दिख रहे हैं उसके चारों ओर आपको घेरे दिखाई दे रहे होंगे या ट्रांसपेरेंट जोन दिखाई दे रहे होंगे। तो जो कैप्सूल अगर उपस्थित होगा तो वहीं पे आपको ट्रांसपेरेंट जोन दिखेगा। अगर कैप्सूल नहीं होगा तो वो ट्रांसपेरेंट जोन जो है वो नहीं दिखाई देगा। तो इस तरह से आप कैप्सुलेटेड और नॉन कैप्सुलेटेड जो फॉर्म्स हैं उनको आइडेंटिफाई कर सकते हैं। नेक्स्ट करेंगे। अब आते हैं हम लोग कुछ बायोकेमिकल जो कैरेक्टराइजेशंस हैं। बायोकेमिकल कैरेक्टराइजेशन का मतलब जो भी ऑर्गेनिज्म है उनकी जो मेटाबॉलिक एक्टिविटीज किस तरह की हैं, उनकी फिजियोलॉजी कैसी है, इसको पता करने के लिए हम उनका बायोकेमिकल कैरेक्टराइजेशन करते हैं, जो कि इसके आइडेंटिफिकेशन के एक काफी इंपॉर्टेंट पैरामीटर्स होते हैं। सबसे पहला जो टेस्ट है वो है आपका इम्बिक टेस्ट। नाम सुने हैं आप लोग सभी लोग इम्बिक टेस्ट का? नहीं सुने हैं? इम्बिक टेस्ट 4 टेस्ट का एक कॉम्बिनेशन होता है। इसमें 4 तरह के टेस्ट होते हैं। एक है आपका इंडोल टेस्ट, मेथाइल रेट टेस्ट, ओगस ब्रास्कर टेस्ट और साइमन साइट्रेट टेस्ट। ये 4 तरह के टेस्ट का जो कॉम्बिनेशन है उसको इम्बिक टेस्ट कहा जाता है। और ये टेस्ट काफी मतलब इंपॉर्टेंट टेस्ट हैं जो जनरली लेबोरेटरीज में की जाती हैं आइडेंटिफिकेशन पर्पस के लिए। तो इमिक टेस्ट में जैसे इंडोल टेस्ट है, इसमें हम ट्रिप्टोन ब्राथ का उपयोग करते हैं। MRVP मतलब मिथाइल रेड और ओगस फ्रास्कर टेस्ट के लिए हम लोग MRVP ब्राथ एक आता है स्पेसिफिकली, उसका यूज करते हैं। और सीमेन साइट्रेट के लिए सीमेन साइट्रेट मीडिया का उपयोग किया जाता है। तो इस तरह से इसमें मैंने उसके कुछ फिगर्स भी लगा रखे हैं, जिसमें कि पहला जो टेस्ट है वो इंडोल टेस्ट का है ना, जिसमें कि हमने कौन सा यूज किया था मीडिया, ट्रिप्टोफैन ब्रॉथ। तो ट्रिप्टोफैन से क्या बनता है, यहाँ पे इंडोल बनता है। तो जब ट्रिप्टोफैन से इंडोल बनेगा तो उसमें हमको एक जो ट्यूब है जिसमें हमने बैक्टीरिया को रखा हुआ है, उसमें जैसे ही हम उसमें रिएजेंट डालते हैं, इंडोल टेस्ट के लिए अल्फा नेप्थाल रिएजेंट का उपयोग किया जाता है। तो जैसे उसमें अल्फा नेप्थाल डालेंगे तो उसमें हमको यदि वो पॉजिटिव है तो ऊपर में ट्यूब के ठीक ऊपर एक पिंक कलर की रिंग आपको दिखाई देगी, वो पॉजिटिव टेस्ट को प्रदर्शित करता है। और अगर वो रिंग नहीं बनती है, येलो कलर दिखाई देता है, तो वो इंडोल नेगेटिव टेस्ट को प्रदर्शित करता है। नेक्स्ट है आपका मिथाइल रेड टेस्ट, सेम वैसे ही है, उसमें भी MRVP ब्राथ का उपयोग करते हैं। ऑर्गेनिज्म को ग्रो करते हैं, ऑर्गेनिज्म को ग्रो करने के बाद उसमें हम मिथाइल रेड इंडिकेटर जो नॉर्मल एक इंडिकेटर है उसका हम उसमें उपयोग करते हैं। तो अगर वो रेड कलर डेवलप करता है तो फिर मिथाइल रेड पॉजिटिव है, और अगर वो येलो रंग कलर का दिखाई देता है तो वो मिथाइल रेड नेगेटिव माना जाता है। इसी तरह से आपका ओगस फ्रास्कर जो है, इसके लिए कोवेक्स रिएजेंट एक रिएजेंट आता है, उसका उपयोग किया जाता है। और उसमें भी हम पॉजिटिव और नेगेटिव टेस्ट को ही देखते हैं। सीमेन साइट्रेट जो है, देखिए उसमें कलर चेंज हो जाता है, जो ग्रीन कलर का जो मीडिया होता है सिट्रेट मीडिया, वह जो है ब्लू कलर में कन्वर्ट हो जाता है। इस तरह से उसको हम देख पाते हैं कि कौन सा पॉजिटिव टेस्ट है और कौन सा नेगेटिव टेस्ट है, और उसका आगे फिर हम आइडेंटिफिकेशन में इन सारे जो बायोकेमिकल कैरेक्टर्स हैं उनका हम उपयोग करते हैं। आज अभी आगे मैं बताऊंगी, नेक्स्ट करेंगे। फिर कुछ एंजाइमेटिक ऐसे भी करते हैं, एंजाइमेटिक टेस्ट भी करते हैं कि हमारा जो ऑर्गेनिज्म है वो कौन कौन सा एंजाइम प्रोड्यूस करता है या कैपेबल है कौन सा एंजाइम प्रोड्यूस करने में। जैसे में पहला टेस्ट है आपका कैटलेज टेस्ट। ये दिस टेस्ट इज यूज्ड टू आइडेंटिफाई ऑर्गेनिजम्स दैट प्रोड्यूस द एंजाइम कैटलेज। दिस एंजाइम डिटॉक्सिफाई hydrogen peroxide by breaking it down into water and oxygen gas. The bubbles resulting from production of oxygen gas clearly indicate a catalase positive present. इसमें क्या होगा कि हम केवल सिंपल एक स्लाइड में थोड़ा सा कल्चर लेते हैं, और कल्चर लेकर के उसमें 2-3 बूंदे क्या डाल देते हैं, हाइड्रोजन पेरोक्साइड की डाल देते हैं। तो यदि उसमें बबलिंग होती है, मतलब बहुत जल्दी उसमें ऑक्सीजन गैस निकलने लगती है, तो वो होता है आपका कैटलेस पॉजिटिव। और अगर नहीं निकलती है तो कैटलेस निगेटिव। जनरली जो है एरोबिक जितने भी बैक्टीरिया होते हैं वो सारे कैटलेस पॉजिटिव होते हैं, है ना, क्योंकि कैटलेस एंजाइम जो है वही ऑक्सीजन मतलब इसकी रक्षा करता है। नेक्स्ट है आपका ऑक्सीडेस टेस्ट है। नेक्स्ट ऑक्सीडेस टेस्ट में क्या करते हैं, इसमें भी एक बायोकेमिकल टेस्ट है जो आइडेंटिफाई करता है ऑक्सीडेस साइटोक्रोम जो एंजाइम है, साइटोक्रोम C ऑक्सीडेस जो एंजाइम है उसके लिए क्या माइक्रो ऑर्गेनिज्म कैपेबल है उसको प्रोड्यूस करने के लिए या नहीं है। तो उसके लिए ऑक्सीडेस टेस्ट का परफॉर्म किया जाता है। इसमें हम क्या करते हैं, छोटे से फिल्टर पे, बहुत ही सरल टेस्ट है। इसमें हम फिल्टर पेपर को सोक करते हैं कोवेक्स ऑक्सीडेस रिएजेंट से, और उसके बाद उसको ड्राई होने देते हैं। ड्राई होने के बाद थोड़ा सा लूप पुल अप कल्चर लेते हैं और उसमें हम उसको स्ट्रिक कर देते हैं या थोड़ा सा उसमें हम लगा देते हैं, और हम ऑब्जर्व करते हैं कि उसका कलर जो है वो चेंज हो रहा है या नहीं हो रहा है। नेक्स्ट करेंगे। इसमें देखिए जो ऑक्सीडेस पॉजिटिव टेस्ट है उसमें हमको क्या दिख रहा है, डार्क कलर दिख रहा है, ब्लू कलर या थोड़ा ब्लैकनिंग टाइप का या पर्पल कलर का दिखाई देता है, जबकि नेगेटिव टेस्ट में हमको कोई भी कलर दिखाई नहीं देता। तो इस तरह से हम ऑक्सीडेस टेस्ट को परफॉर्म करते हैं। नेक्स्ट फिर है अमाइलेज, है ना। अमाइलेज के बारे में आप लोग सभी जानते होंगे, बॉटनी जूलॉजी वाले बच्चे हैं, सभी जान रहे हैं कि अमाइलेज क्या होता है। अमाइलेज क्या है, एंजाइम है, क्या करता है, स्टार्च को डिग्रेड करता है, क्या बनाता है, तो यहाँ पे क्या होता है कि एक बायोकेमिकल टेस्ट बैक्टीरियल आइडेंटिफिकेशन में भी इसका उपयोग किया जाता है। बहुत सारे ऑर्गेनिजम्स हैं जो कि एमाइलेज एंजाइम का प्रोडक्शन करते हैं। तो एमाइलेज एंजाइम का प्रोडक्शन ये क्यों करेंगे, यदि वो स्टार्च को एज अ कार्बन सोर्स उपयोग कर पाने में सक्षम होंगे, है ना। मतलब एमाइलेज जो प्रोड्यूस करेगा जो भी ऑर्गेनिज्म, वो क्या कर सकता है, स्टार्च को ग्लूकोज में कन्वर्ट करेगा, जिससे कि उसको क्या होता है कि स्टार्च को डायरेक्टली ले नहीं सकता, क्योंकि स्टार्च के मॉलिक्यूल्स क्या होंगे, मैक्रो मॉलिक्यूल है, तो वो बड़ा मॉलिक्यूल होता है, उसका जो ट्रांसपोर्ट सिस्टम है उसको अंदर प्रवेश करने नहीं देगा। जबकि यदि उसको ग्लूकोज में कन्वर्ट कर दे तो वो ग्लूकोज क्या है, बहुत ही छोटा मॉलिक्यूल है, तो वो आराम से उसका ट्रांसपोर्टेशन हो सकता है। तो इसलिए वो क्या करता है, स्टार्च को पहले वो एक एक्सो एंजाइम फार्म करता है, एमाइलेज एक्सो एंजाइम, जो कि बाहर निकलता है ना, और आसपास उसका जो मीडिया है या जो भी उसका इन्वायरमेंट है वहां पे यदि स्टार्च कंटेंट है तो उसको वो पहले हाइड्रोलाइज करता है, ग्लूकोज में कन्वर्ट करता है, और उसके बाद उसको एज अ फूड या एज अ न्यूट्रिशन सोर्स वह ग्रहण करता है और लेता है। जिससे कि यदि वो स्टार्च, इसके लिए हम लोग मीडिया जो यूज करते हैं उस मीडिया का नाम है स्टार्च अगार मीडिया, जिसमें कि जो सामान्य न्यूट्रिएंट मीडिया है उसमें ही हम 1% स्टार्च जो है उसका सप्लीमेंट किया जाता है। स्टार्च रहने के कारण जब हम उसकी, जैसे कि स्ट्रीकिंग जैसे मैंने बताया आपको, इसमें भी हम हमको क्या करना है, स्ट्रीकिंग ही करना है बैक्टीरियल कल्चर का। स्ट्रीकिंग करने के बाद इसको इंक्यूबेट करेंगे ताकि उसकी ग्रोथ हो जाए। ग्रोथ होने के बाद हम क्या करते हैं, उसमें हम ल्यूगाल्स आयोडीन या आयोडीन सोल्यूशन डालने पर, आप सभी जान रहे हैं कि स्टार्च आयोडीन के साथ में रिएक्शन करता है तो कौन सा कलर डेवलप होता है, ब्लू कलर, इंडिगो कलर डेवलप होता है ना। तो उस तरह से उसमें कलर डेवलप हो जाता है। तो जहां जहां स्टार्च होगा वो रीजन कैसा होगा, ब्लू होगा, और जो रीजन पे स्टार्च नहीं होगा वो कलर कैसा होगा, कलरलेस हो जाएगा। तो देखिए इसमें दो तरह के ऑर्गेनिज्म दिख रहे हैं। एक देखिए, एक लाइन है जिसके चारों तरफ डार्क दिख रहा है, मतलब वो क्या है, एमाइलेज नेगेटिव है। और दूसरा है जिसके चारों तरफ एक हालो रीजन दिख रहा है जो चमकता हुआ दिख रहा है, मतलब वहां से स्टार्च को उसने गायब कर दिया है ना, उसको खत्म कर चुका है। इसलिए क्या होगा, एक हालो रीजन, मतलब वो एमाइलेज एंजाइम का प्रोडक्शन कर रहा है, जिसके कारण वहां पे आपको एक ट्रांसपेरेंट जोन जो है वह दिखाई देता है जहां जहां उसकी ग्रोथ होती है। तो ये हो गया एमाइलेज टेस्ट। इसका उपयोग, पीछे कीजिए, एमाइलेज टेस्ट का उपयोग किसके करते हैं, टू डिफरेंशिएट स्पीसीज ऑफ बेसिलस, क्लास्ट्रीडियम, फॉरिनोबैक्टीरियम, इनको जो डिफरेंशिएट करने के लिए, और एंटेरोकोकस और स्यूडोमोनास के जीनस को डिफरेंशिएट करने के लिए एमाइलेज टेस्ट का उपयोग किया जाता है। नेक्स्ट, फिर आता है आपका लाइपेज। लाइपेज एंजाइम एक ऐसा एंजाइम है जो कि लिपिड का डिग्रेडेशन करता है। तो हमको मीडिया का कैसा लेना है हमको, जिसमें कि लिपिड हो, लिपिड कंटेनिंग मीडिया का इसमें उपयोग किया जाता है, जिसमें जनरली जो है ट्राइब्यूटरीन मीडिया या जिसको अपन कहते हैं ट्राइग्लिसराइड्स का इसमें उपयोग करते हैं। ट्विन 20 या ट्विन 80 के रूप में इनका उपयोग किया जाता है। तो ऐसे मीडिया जो कि सप्लीमेंटेड विद द लिपिड कंटेंट, उसमें हम ऑर्गेनिज्म को ग्रो करते हैं, और ऑर्गेनिज्म को ग्रो करने के बाद देखिए इसकी कॉलोनी कैसे दिखाई देती है। इस तरह से उसमें हमको व्हाइट कलर की प्रेसिपिटेटेड कॉलोनीज दिखाई देती हैं अराउंड द ग्रोथ। उसको अपन कहते हैं कि लाइपेज पॉजिटिव, मतलब ये लिपिड को हाइड्रोलाइज कर पा रहे हैं, और जो नहीं दिख रहे हैं मतलब वो लिपिड को हाइड्रोलाइज नहीं कर पा रहे हैं। तो इस तरह से हम लाइपेज टेस्ट का भी स्टडी करते हैं। नेक्स्ट करेंगे। फिर है आपका यूरियस टेस्ट। यूरियस टेस्ट किसके लिए करते हैं, दिस टेस्ट इज यूज्ड टू आइडेंटिफाई बैक्टीरिया capable of hydrolyzing urea using the enzyme urease. It is commonly used to distinguish the genus Proteus from the other enteric bacteria. जो दूसरा एंटेरिक बैक्टीरिया है उससे हमको प्रोटियस को अलग करना है, उसके लिए हमको यूरियस टेस्ट का इस्तेमाल करना होता है, जिसमें कि मीडिया हम यूज करते हैं यूरिया ब्राथ मीडिया। ये जो यूरियस एंजाइम है ये क्या करता है, यूरिया को डिग्रेड करता है और डिग्रेड करके उसको अमोनिया और कार्बन डाइऑक्साइड में कन्वर्ट कर देता है, जिसके कारण जो मीडिया होता है उसका पीएच, जैसे अमोनिया निकलेगा उसमें से उसका पीएच कैसा हो जाएगा, बदल जाता है ना, कैसा होगा, वो एल्कलाइन पीएच में चला जाता है। तो इसलिए इसमें एक इंडिकेटर डला होता है फिनॉल रेड, जो कि येलो कलर से या ऑरेंज कलर से उसका कलर पिंक कलर में बदल जाता है। तो पॉजिटिव अगर यूरियस का प्रोडक्शन होगा तो हमको जो मिलेगा मीडिया वो कैसा मिलेगा, पिंक कलर का दिखाई देगा। यदि यूरियस का प्रोडक्शन नहीं हो रहा है तो एज इट इज जैसा मीडिया था वैसा ही हमको दिखाई देगा ऑरेंज कलर का। नेक्स्ट करेंगे। फिर है शुगर फर्मेंटेशन टेस्ट। शुगर फर्मेंटेशन टेस्ट में हम लोग जनरली जो है टीएसआईए टेस्ट को का उपयोग करते हैं। टीएसआईए का मतलब होता है ट्रिपल शुगर आयरन अगार मीडिया। ट्रिपल शुगर मतलब इसमें कितने शुगर होंगे, 3 तरह के शुगर्स होंगे। तो 3 तरह के शुगर्स का इसमें इनकॉर्पोरेशन होता है, जिसमें कि ग्लूकोज, डेक्सट्रोज है, ग्लूकोज है, और डेक्सट्रोज है, सुक्रोज है और लैक्टोज, ये 3 तरह के जो शुगर्स हैं उनको देखते हैं कि इनका फर्मेंटेशन ये कर पा रहे हैं कि नहीं कर पा रहे हैं। इसके अलावा इसमें हाइड्रोजन सल्फाइड गैस के प्रोडक्शन को भी देखा जाता है कि जो ऑर्गेनिज्म है क्या वो हाइड्रोजन सल्फाइड गैस प्रोड्यूस कर रहे हैं या नहीं कर रहे हैं। इसके लिए करते हैं टू डिफरेंशिएट द ग्राम नेगेटिव एंटेरिक बेसिलाई। जो ग्राम नेगेटिव एंटेरिक जो बेसिलाई है उनको डिफरेंशिएट करने के लिए इस टेस्ट का उपयोग किया जाता है। इसके अलावा लैक्टोज फर्मेंटर और नॉन लैक्टोज फर्मेंटर को भी आइडेंटिफाई करने के लिए इसका उपयोग किया जाता है। जिसमें कुछ मैंने आपको जो इमेज दिखाया है उसमें देखिए अलग अलग तरह के कलर्स दिख रहे होंगे। जो ये TSIA मीडिया होता है उसमें भी एक इंडिकेटर रहता है जिसके कारण उसका कलर होता है लाल, जैसे तीसरे नंबर में दिख रहा है ना, वैसे कलर का दिखाई देता है। तो इस तरह के स्लांट्स बनाए जाते हैं और स्लांट्स बना करके उसके ऊपर स्ट्रिकिंग करते हैं हम लोग, जैसे स्ट्रिक प्लेट करते हैं वैसे ही अब स्लांट के ऊपर पतली सी जो भी आपका ऑर्गेनिज्म है, आइसोलेटेड जो प्यूरिफाइड कल्चर है, उसकी स्ट्रिक बनाई जाती है, स्ट्रिकिंग करते हैं, इंक्यूबेशन करते हैं ताकि उसकी प्रॉपर ग्रोथ हो, और उसके बाद उसको ऑब्जर्व करते हैं। ऑब्जर्व करने पर हमको तरह तरह की चीजें दिखाई देती हैं। जैसे देखिए कुछ जो ऑर्गेनिज्म है ना, कुछ जो ट्यूब्स है उसमें नीचे का पोर्शन येलो दिख रहा है और ऊपर का पोर्शन पिंक दिख रहा है। कुछ ऐसा है जो पूरा ही पिंक दिखाई दे रहा है, कुछ ऐसा है जिसमें पूरा येलो है लेकिन उसमें स्प्लिटेड मीडिया दिखाई दे रहा है, बीच बीच में हमको टूटा हुआ मीडिया दिख रहा है। और कुछ एक और ट्यूब है जिसमें कि हमको ब्लैकनिंग दिखाई दे रही है या ब्लैक कलर दिखाई दे रहा है। इन सब का अलग अलग मतलब होता है, वो क्या होता है नेक्स्ट स्लाइड में देखते हैं। ये देखिए जैसे पहला वाला जो ट्यूब है इसमें वो क्या है, कंट्रोल है। कंट्रोल का मतलब क्या होता है, जिससे हम कंपेयर करते हैं, मतलब उसमें सब चीज होगा, उसका इंक्यूबेशन टेम्परेचर भी वैसा होगा, हर चीज हम वैसे ही करेंगे, केवल उसमें हम ऑर्गेनिज्म नहीं डालते हैं। जो भी हमको स्टडी करना है उसको हम नहीं डालते हैं, बाकी सब चीज उसको वैसे ही रन किया जाता है। कंट्रोल ऐसा दिखाई देता है। उसके बाद दूसरा है, देखिए पीले रंग का दिख रहा है ना, और नीचे क्या दिख रहा है उसमें गैस प्रोडक्शन, मतलब यहाँ पे येलो हो रहा है मतलब एसिड का प्रोडक्शन हो रहा है, लैक्टोज से लैक्टिक एसिड बन रहा है, और नीचे क्या हो रहा है, गैस का प्रोडक्शन हो रहा है। तो एसिड एंड गैस प्रोडक्शन किसमें होता है, एस्चेरिचिया कोलाई में होता है। अगर उसमें ई कोलाई होगा तो हमको TSIA का रिजल्ट जो सेकेंड ट्यूब है उसके जैसा दिखाई देगा। इसी प्रकार से जो तीसरा ट्यूब है दैट इज फॉर द साल्मोनेला टाइफी, जिसमें देखिए नीचे जो उसको बोलते हैं बट इसका येलो है, और जो स्लांट वाला पोर्शन है वो कैसा है, पिंक कलर का दिखाई दे रहा है। इसके अलावा उसमें हल्की सी ब्लैकनिंग भी दिख रही है। इसी प्रकार से जो प्रोटियस वल्गेरिस है वो देखिए उसमें काफी ज्यादा इसका जो बट है वो भी पूरे ब्लैकनिंग हो चुका है। फिर नेक्स्ट है आपका आपका सिट्रोबैक्टर है। सिट्रोबैक्टर देखिए येलो कलर है और नीचे उसका जो बट है वो ब्लैकनिंग है। साल्मोनेला टाइफ्यूरियम का दूसरा एक और स्ट्रेन है जो कि एक अलग तरह से हमको दिखाई दे रहा है, 6वें नंबर का ट्यूब है जो कि ब्लैकनिंग है और ऊपर वाला पोर्शन उसका पिंक है। सिजेला, सिजेला में देखिए गैस प्रोडक्शन भी हो रहा है, इसका जो बट है वो येलो कलर का होगा लेकिन जो स्लांट है वो पिंक कलर का होता है। तो इस तरह से ये अलग अलग तरह के शुगर्स का फर्मेंटेशन करते हैं और गैस का प्रोडक्शन करते हैं। जो फर्मेंट किसी को भी फर्मेंट नहीं करेंगे किसी भी शुगर को तो उसमें कोई चेंज भी हमको दिखना नहीं होगा या नहीं दिखेगा। नेक्स्ट करेंगे। फिर अब ये सारे जो बायोकेमिकल टेस्ट हैं और इसके साथ साथ में जो आपके मार्फोलॉजिकल जो टेस्ट हैं है ना, जैसे आपने किया स्टेनिंग किया, तरह तरह की स्टेनिंग किया, वो मार्फोलॉजिकल स्टडी हुआ उसका कि कैसा शेप में है, कैसा अरेंजमेंट है, ग्राम पॉजिटिव है कि ग्राम नेगेटिव है, फ्लैजिला है कि नहीं है। अगर फ्लैजिला है तो मोटाइल होगा, फ्लैजिला नहीं है तो नॉन मोटाइल होगा, है ना। इसी तरह से एंडोस्पोर का फॉर्मेशन हो रहा है कि एंडोस्पोर का फॉर्मेशन नहीं हो रहा है, ये सारे मार्फोलॉजिकल स्टडीज। इसके अलावा जो मैंने जो इतने सारे जो टेस्ट बताए दे आर द बायोकेमिकल स्टडी, वो बायोकेमिकल टेस्ट है। तो इनके आधार पर मार्फोलॉजिकल स्टडी और बायोकेमिकल टेस्ट के आधार पर बर्गेस मेनुअल ऑफ बैक्टीरियल क्लासिफिकेशन जो है वो दिया गया है। बर्गेस मेनुअल ऑफ डिटर्मिनेटिव बैक्टीरियोलॉजी करके एक बुक है जिसके कई वॉल्यूम्स हैं, जिसमें कि इन कैरेक्टर्स के आधार पर बैक्टीरिया को क्लासीफाई किया गया है कि उसको हम किस क्लास में रखेंगे और उसका प्रॉपर जो है जीनस लेवल तक, स्पीसीज लेवल तक आइडेंटिफिकेशन हम इनके बेसिस पर कर सकते हैं। और पहले इसी एक ट्रेडिशनल मेथड है जो कि पहले इसी मेथड से ही बैक्टीरियल आइडेंटिफिकेशन किया जाता था, लेकिन अभी जो है जब से थोड़ा सा मतलब मॉडर्नाइजेशन आया और जब सीक्वेंसिंग की प्रोसेसेस आई उसके बाद जो है अब मॉलिक्यूलर कैरेक्टराइजेशन पे जाते हैं और हम अब क्या करते हैं कि सीक्वेंसिंग करा लेते हैं। इतना करने के बाद हम सीक्वेंसिंग करा लेते हैं और सीक्वेंसिंग कराकर हमको स्पीसीज लेवल तक का आइडेंटिफिकेशन हम उसमें कर सकते हैं। उसका DNA कैसा है, उसका जीन में किस तरह का कैसा सीक्वेंस है, उसके आधार पर उसको हम आइडेंटिफाई कर लेते हैं। तो दिस इज द आइडेंटिफिकेशन प्रोसेस। नेक्स्ट। अब आपने आइसोलेट किया तो उसके प्रिजर्वेशन के भी कुछ प्रोसेसेस हैं कि हम उसको कैसे प्रिजर्व करें, या एक बार हमने आइसोलेट किया तो एक बार आइसोलेट करके उसको हम फेंकेंगे नहीं, है ना, उसको हम क्या करेंगे, मेंटेन करके रखेंगे क्योंकि हम उसकी फर्दर स्टडी कर पाए, या हम अगर नहीं कर पा रहे हैं तो कोई दूसरा जो है व्यक्ति है उसकी फर्दर स्टडी कर पाए। उसके लिए बहुत सारे मेथड्स हैं जिसमें है आपका क्रायो प्रिजर्वेशन यूनिट्स, जिसमें आप -80 डिग्री सेंटीग्रेड से -196 डिग्री सेंटीग्रेड पर आप रख सकते हैं ऑर्गेनिज्म को। उसका आगे मेटाबॉलिक रिएक्शन बंद हो जाएगा वहाँ पे, और इस तरह से वो डॉर्मेंट कंडीशन में चला जाता है। जब कभी उसको बाहर निकालेंगे तो रिवाइव हो जाता है कल्चर। इसी प्रकार से लायोफिलाइजर है। लायोफिलाइजर क्या करता है? फ्रीज ड्रायर है। इसमें हम फ्रीज ड्राइंग करते हैं, जिससे कि उसका जो वाटर कंटेंट है उसको एक्सट्रैक्ट कर लिया जाता है, और उसको हम बहुत लंबे समय तक, जो स्पोर फार्मर्स हैं उनको भी और नॉन स्पोर फार्मर्स हैं उनको, जो छोटे छोटे जो वायल्स होते हैं, लायोफिलाइज्ड वायल्स होते हैं, उसमें हम उसको स्टोर करके रख सकते हैं। और जब कभी उसमें हम न्यूट्रिएंट मीडिया ऐड करेंगे तो वो फिर से अंकुरित हो जाते हैं और नए सेल्स को बनाने लगते हैं। फिर है क्रायोवायल्स। फिर प्रिजर्वेशन टेक्निक्स में शॉर्ट टर्म स्टोरेज और लॉन्ग टर्म स्टोरेज। जैसे कि कहा कि शॉर्ट टर्म स्टोरेज में आप तो सिंपल आप रेफ्रिजरेटेड आप फ्रिज में रख सकते हैं 4 डिग्री सेंटीग्रेड पर। उसको बीच बीच में आपको क्या करना पड़ेगा? रिवाइव करना पड़ता है। जैसे हर 15 दिन में आप हर 15 डेज में उसको नए मीडिया में डालिए, ताकि उसमें अगर मीडिया एग्जॉस्ट हो गया है या ड्राइंग वगैरह का जो प्रोसेस है अगर ड्राई हो चुका है, तो हम नए मीडिया में ट्रांसफर करने पर वो तुरंत ही फ्लरिशिंग ग्रोथ शो करने लगते हैं। इसके अलावा लॉन्ग टर्म अगर है तो उसके लिए हम क्रायो प्रिजर्वेशन का इस्तेमाल करते हैं कि अगर बहुत हमको सालों साल तक ऑर्गेनिज्म को स्टोर करके रखना है तो उसके लिए हम क्रायो प्रिजर्वेशन का इस्तेमाल करते हैं। नेक्स्ट करेंगे। अब आते हैं हम मोस्ट प्रोबेबल नंबर या एमपीएन टेस्ट। एमपीएन टेस्ट जैसे बेसिकली एक ये जो टेस्ट है वो बेस्ड है स्टैटिस्टिकल मेथड्स पे, मतलब स्टैटिस्टिक्स पर बेस्ड है ये टेस्ट, जो है ना, एमपीएन टेस्ट। और ये जो टेस्ट है इसका जो उपयोग हम लोग किसके लिए करते हैं? जो ड्रिंकिंग वाटर है उसकी पोर्टेबिलिटी को चेक करने के लिए जनरली जो है इसका उपयोग किया जाता है। मोस्ट प्रोबेबल नंबर इसको कहते हैं। इट इज एन स्टैटिस्टिकल मेथड टू एस्टिमेट द बैक्टीरियल लोड बेस्ड ऑन द रैंडम डिस्पर्सन ऑफ द माइक्रो ऑर्गेनिज्म पर वॉल्यूम इन गिवन सैंपल। किसी भी सैंपल में पर वॉल्यूम में, मतलब उसका 1 ml में या 100 ml में या 10 ml में कितना उसमें सेल्स है, कितना बैक्टीरियल सेल है, उसको हम एस्टिमेट करने के लिए एमपीएन का उपयोग करते हैं। ये जो इसका जो प्रिंसिपल है, इट इज बेस्ड ऑन द एसिड एंड गैस प्रोडक्शन इन द लैक्टोज ब्राथ। लैक्टोज ब्राथ मीडियम का जनरली इसमें उपयोग किया जाता है, जिसमें कि एसिड का प्रोडक्शन और गैस का प्रोडक्शन को देखा जाता है। इसके जो की इक्विपमेंट्स हैं, जैसे कि पहले के जो इक्विपमेंट्स हैं वो तो सब रहेंगे ही इसमें। इसके अलावा जो इक्विपमेंट्स और लगेंगे वो है आपका डूरहम्स ट्यूब। छोटे छोटे ट्यूब्स होते हैं जिनको अपन कहते हैं डूरहम्स ट्यूब टू कैप्चर द गैस एंड द लैक्टोज ब्राथ एज अ कल्चर मीडियम। मीडियम के रूप में हम लैक्टोज ब्राथ का उपयोग करते हैं। ये जो टेस्ट है, एमपीएन जो टेस्ट है, यह 3 स्टेजेस में कंप्लीट होता है। 3 उसके स्टेप्स हैं। पहला है आपका प्रिजम्पटिव टेस्ट, देन है कंफर्मेटरी टेस्ट एंड कंप्लीटेड टेस्ट। ये है आपका प्रिजम्पटिव टेस्ट। देखिए प्रिजम्पटिव टेस्ट में 3 सेट हम लेते हैं टेस्ट ट्यूब्स की, ठीक है, और इसमें सब में हम डालते हैं लैक्टोज ब्राथ मीडियम। 2 जो सेट है, जो आपका आखिरी वाला जो सेट है जिसमें 0.1 ml लिखा है, और दूसरा जो उसके पहले वाला जिसमें 1 ml लिखा है, उन दोनों सेट में हम 1x मीडिया डालते हैं। 1x मीडिया मतलब जिसकी पोटेंसी सिंगल है, 1x मीडिया। कौन सा मीडिया है? लैक्टोज ब्राथ मीडिया। और उसके बाद जो तीसरा जो ट्यूब है जिसमें कि 10 ml लिखा हुआ है, उसमें हम डालते हैं 2x मीडिया। 2x मीडिया मतलब जिसकी पोटेंसी डबल स्ट्रेंथ मीडिया है, मतलब जितना केमिकल हम 100 ml में 1x में डालेंगे उसका ठीक डबल जो है वो हम 100 ml में इसमें डालेंगे। हम सेकेंड पहले वाला जो सेट है उसके लिए उसका उपयोग किया जाता है। सभी ट्यूब्स में हम मीडिया ले लेते हैं 10-10 ml जो लैक्टोज ब्राथ है, जैसे कि पहले वाले सेट में 2x मीडिया लिया और दूसरे और तीसरे सेट में 1x मीडिया लिया, और उसमें हम क्या डाल देते हैं? डूरहम्स ट्यूब। जो छोटे छोटे अंदर में छोटे छोटे ट्यूब्स होते हैं, आप लोग केमिस्ट्री में शायद वो प्रैक्टिकल में उसको जलाने वालाने के लिए जो डूरहम्स ट्यूब का उपयोग करते हैं ना, वही सेम ट्यूब है, इनका इस्तेमाल किया जाता है। जो कि उसमें हम इन्वर्टेड कंडीशन में करते हैं कि जब कभी उसमें गैस वगैरह का प्रोडक्शन होगा तो क्या होगा? डूरहम्स ट्यूब ऊपर की तरफ मूव करता है, ऊपर की तरफ आने लगता है, जिससे कि हमको गैस में दिखाई या गैस के बबल्स उसमें दिखाई देते हैं। तो इस तरह से हम इसको सेट करते हैं एक्सपेरिमेंट। अब हमारा जो वाटर सैंपल है, देखिए वो जो पहला वाला जो रखा हुआ है सबसे सामने एक फ्लास्क में, वो है आपका सैंपल जिसको आपने कलेक्ट करके लाया है, जिसमें आपको क्या टेस्ट करना है? उसका एमपीएन टेस्ट करना है। अभी आप लोग खूब सुन रहे होंगे दिल्ली में यमुना का एमपीएन इतना हो गया है और उतना हो गया है, रोज टीवी में दिखा रहा है कि इतना एमपीएन इतने 100 तक चला गया है, चला गया। यही सेम टेस्ट है एमपीएन टेस्ट। ये बहुत काम का टेस्ट है, जनरली लेबोरेटरीज में इसी टेस्ट का ही इस्तेमाल किया जाता है। अब देखिए हमने क्या किया, 3 सेट लिया, तीनों में हमने 10-10 ml लैक्टोज ब्राथ मीडिया को डिस्पेंस किया, और उसके बाद उसमें डूरहम्स ट्यूब डाल देते हैं। डूरहम्स ट्यूब्स कैसे हैं? इन्वर्टेड कंडीशन में। अब तीनों में अलग अलग अमाउंट ऑफ द सैंपल हम डालते हैं। पहला वाला जो सेट है उसमें हम 10 ml सैंपल डालते हैं, और इसीलिए हमने उसमें डबल स्ट्रेंथ मीडिया लिया था, क्योंकि उसमें हमारा सैंपल साइज काफी बड़ा था। तो अगर बहुत सिंगल स्ट्रेंथ लेंगे तो उसमें प्रॉपर उसका रिएक्शन नहीं हो पाएगा, इसलिए वहां पे हमने डबल स्ट्रेंथ मीडिया को उपयोग किया था। सेकेंड जो सेट है उसमें हम लेते हैं 1 ml सैंपल पांचों में, और आखिरी वाला है उसमें 0.1 ml, और इसके साथ साथ में एक कंट्रोल ट्यूब भी रन किया जाता है। इसमें एक इंडिकेटर डलाता है, उसका नाम है ब्रोमोक्रिसाल पर्पल। लैक्टोज ब्राथ के अलावा ब्रोमोक्रिसाल पर्पल एक इंडिकेटर का उपयोग करते हैं, जो कि पर्पल कलर डेवलप होता है सामान्य कंडीशन में। लेकिन यदि उसमें एसिड प्रोडक्शन हो रहा है, मतलब अगर उसका पीएच लोअर होगा तो उसका कलर चेंज होगा, और पर्पल टू क्या हो जाता है, वो येलो कलर हो जाता है। ये करने के बाद हम क्या करेंगे, इसको इंक्यूबेट कर देते हैं प्रॉपर टेम्परेचर, दैट इज द 37 डिग्री सेंटीग्रेड फॉर द 24 टू 48 आवर्स। 24 से 48 आवर्स के लिए इसको प्रॉपर इसका इंक्यूबेशन दिया जाता है। इंक्यूबेशन के बाद हम चेक करते हैं कि उन ट्यूब्स में हुआ क्या है। देखिए पहला वाला ट्यूब दिख रहा है, कैसे दिख रहा है, कलर चेंज दिख रहा है। दूसरे में भी कलर चेंज दिख रहा है, कुछ में चेंज है कुछ में नहीं है। तीसरे में कुछ में चेंज है कुछ में नहीं है। तो ये जो तीन तरह के जो सेट हैं, इनमें कितने ट्यूब्स का किस तरह का रिएक्शन है, ये हमारे लिए बहुत ज्यादा इंपॉर्टेंट होता है। नेक्स्ट करेंगे, और उसके आधार पर ये टेबल बनाया जाता है कि कितने ट्यूब्स पॉजिटिव। पॉजिटिव का मतलब है जिसमें कि एसिड एंड गैस का प्रोडक्शन हुआ है, मतलब कलर चेंज हुआ है प्लस उसमें गैस की बबलिंग भी हुई हो या कलर भी चेंज हुआ हो, ठीक, वो पॉजिटिव रिएक्शन है। नेगेटिव रिएक्शन जिसमें किसी तरह का कोई चेंज हमको नहीं दिखेगा, ना बबल बनेंगे और ना ही किसी तरह का उसमें कलर में परिवर्तन होगा। तो उसके आधार पर ये तीन जो टेबल है बने हुए हैं। देखिए जैसे कि 10 ml वाले हैं, है ना, 10 ml पहला वाला सेट था 10 ml वाला, यदि उसमें किसी में भी कोई चेंज नहीं है, इसका मतलब उसका वैल्यू कितना है, 0। इसी तरह से नेक्स्ट है आपका 1 ml वाला, उसमें भी अगर कोई चेंज नहीं है तो उसका भी वैल्यू क्या हो गया, 0। और तीसरे में भी चेंज नहीं है तो उसका भी वैल्यू क्या हो गया, 0। तो उस समय उसका एम्पियन जो इंडेक्स आता है वो हमेशा पर 100 ml आता है। एम्पियन जो इंडेक्स है वो हमेशा पर 100 ml हम अपने को कैलकुलेट करना रहता है। उस समय इसका जो एम्पियन है वो क्या हो जाएगा, लेस देन 2 होगा, मतलब बहुत ही कम होगा। फिर उसके बाद नेक्स्ट में देखिए इसी तरह से मैं आखिरी में चले जाती हूँ, जहां पे देखिए जो 10 ml वाले ट्यूब थे उसमें कितना हुआ है, 3, नेक्स्ट में 2 और आखिरी में 1, मतलब नंबर ऑफ ट्यूब्स अलग अलग हो सकते हैं। उसके आधार पर उसके सामने देखिए एम्पियन का नंबर कितना दिया है, 17। तो इतने ट्यूब में अगर रिएक्शन दिखा रहा है मतलब उसका एम्पियन इंडेक्स कितना होगा, 17 पर 100 ml। तो इस तरह से हम उसकी पोर्टेबिलिटी को चेक करते हैं कि इसमें बैक्टीरियल लोड कितना है। मतलब 100 ml में 17 हो सकते हैं कोलीफॉर्म्स, इसका मतलब ये है दिस इज द प्रिजिम्टिव टेस्ट। प्रिजिम्टिव का मतलब जिसको हम प्रिज्यूम कर रहे हैं, ऐसा सोच रहे हैं कि इतना होगा, ठीक। नेक्स्ट, सबको क्लियर है, किसी को कोई डाउट है? अब इतना करने के बाद हम क्या करते हैं, इसको हम कंफर्म करते हैं। एक्चुअली क्या होता है कि अदर देन द कोलीफॉर्म्स के अलावा बहुत सारे जो बैक्टीरिया हैं जो कि नॉन कोलीफॉर्म्स हैं और वो भी इस तरह का रिएक्शन शो करते हैं, तो उससे क्या होगा, एक डाउटफुल कंडीशन डेवलप होने का डर होता है। तो इसलिए हम उसको क्या करते हैं, कंफर्म करते हैं। और कंफर्म करने के लिए हम एक दूसरा टेस्ट लगाते हैं और उसको कहते हैं कंफर्मेटरी टेस्ट, जिसमें कि हम मीडिया को थोड़ा सा बदलाव करते हैं। इसमें भी लैक्टोज यूज होता है। लैक्टोज में हम डाल देते हैं BGLB। BGLB का मतलब होता है ब्रिलियंट ग्रीन लैक्टोज ब्राथ मीडिया। इसमें एक बाइल साल्ट डला हुआ होता है, जिसके कारण यह केवल कोलीफॉर्म्स की ग्रोथ को ही प्रमोट करेगा। जैसे कि मैंने बताया था सेलेक्टिव मीडिया, नॉन कोलीफॉर्म्स जो है यहाँ पे ग्रो ही नहीं करते, ठीक है। तो जब कोलीफॉर्म्स इसमें अगर हमारे जो पॉजिटिव ट्यूब्स है और वो उसका जो पॉजिटिव रिएक्शन है, मतलब जो कलर चेंज हुआ, एसिड का प्रोडक्शन हुआ और जो उसमें गैस का प्रोडक्शन हुआ है, वो यदि किसी कोलीफॉर्म की वजह से है तो यहाँ भी वो क्या करेगा, एसिड और गैस का प्रोडक्शन करेगा। और अगर वो नॉन कोलीफॉर्म्स का है तो उसकी तो ग्रोथ ही नहीं होगी, तो इसलिए वो एसिड और गैस का प्रोडक्शन नहीं करेगा। तो ये जो मीडिया है देखिए कैसे कलर का दिख रहा है, ग्रीन कलर का, क्योंकि इसमें ब्रिलियंट ग्रीन एक डाई डला हुआ है। तो जब कभी ऐसे टेस्ट आता है जिसमें कि पहले भी पॉजिटिव था और इसमें BGLB में भी यदि वो गैस का प्रोडक्शन कर रहा है, जो कि डूरहम्स ट्यूब में हमको देखिए लास्ट दिख रहा है, जिसमें कि डूरहम ट्यूब आपको ऊपर उठा हुआ और उसमें गैस बबल दिख रहे हैं, इस तरह का दिखाई देता है, इसका मतलब ये पॉजिटिव टेस्ट है। इसका मतलब उसमें क्या है, कोलीफॉर्म्स कंफर्म है कि उसमें कोलीफॉर्म है। इसके अलावा नेक्स्ट टेस्ट है कोलीफॉर्म कंफर्मेटरी का। नेक्स्ट कीजिए तो। इसके अलावा जो है एक और टेस्ट है कोलीफार्म कंफर्म का। एक तो हम लोग VGLB में करते हैं, दूसरा हम क्या करते हैं, जो पॉजिटिव ट्यूब्स हैं उसको हम स्ट्रिकिंग करते हैं EMB अगार मीडिया में, इयोसिन मेथिलीन ब्लू अगार मीडिया में, इयोसिन मेथिलीन ब्लू अगार मीडिया में। तो EMB अगार जो मीडिया है वो केवल ग्राम नेगेटिव बैक्टीरिया की ग्रोथ को प्रमोट करता है, ग्राम पॉजिटिव बैक्टीरिया आएंगे नहीं। इसके अलावा केवल एंटेरिक बैक्टीरिया की ग्रोथ को प्रमोट करता है, जिसमें कि अलग अलग तरह के एंटेरिक बैक्टीरिया की जो कॉलोनी है वह अलग अलग रंग की दिखाई देती है। जैसे अगर ई कोलाई आया तो ग्रीन कलर की दिखेगी, यदि सीडोमोनास आता है तो पिंक कलर की दिखाई देगा, यदि क्लेप्सियला आता है तो वह पर्पल कलर की कॉलोनी फॉर्म करती है, सीजेला आता है तो वो पिंक कलर की कॉलोनी फॉर्म करती है। तो अलग अलग तरह के जो ऑर्गेनिजम्स हैं उनकी जो कॉलोनीज हैं वो हमको डिफरेंट दिखाई देती हैं। इस तरह से हम बता सकते हैं कि इसमें किसका कंटामिनेशन है, ये जो वाटर है उसमें किस तरह के ऑर्गेनिज्म का कंटामिनेशन है। ठीक है, अब है आपका कंप्लीटेड टेस्ट। कंप्लीटेड टेस्ट यहाँ तक कंफर्म हो गया। कंफर्म होने के बाद हम क्या करते हैं, कंप्लीटेड टेस्ट करते हैं। कंप्लीटेड टेस्ट में हम लोग कुछ भी नहीं है, सिंपल जो है जो भी हमारा कॉलोनी डेवलप हुआ है उसको हम स्टेनिंग करते हैं। न्यूट्रेंट अगार प्लेट में उसकी स्ट्रिक किया जाता है और उसके बाद उसकी स्टेनिंग की जाती है। यदि उसमें वो ग्राम नेगेटिव दिखाते हैं, ग्राम नेगेटिव बैक्टीरिया आते हैं, इसके साथ साथ में इम्बिक टेस्ट भी परफॉर्म किया जाता है कि कितने टेस्ट ने इम्बिक टेस्ट को, कौन कौन से टेस्ट को पॉजिटिव दे रहे हैं और कौन कौन से टेस्ट को नेगेटिव दे रहे हैं करके। तो इस तरह से यह टेस्ट कंप्लीट होता है। नेक्स्ट करेंगे। ये देखिए इसमें मैंने दो अपने प्लेट्स लगाए हैं, जिसमें कि एक में ई कोलाई की ग्रोथ दिख रही है। ई कोलाई की ग्रोथ कैसे दिखती है, ये EMB अगार मीडिया, जो लाल रंग का मीडिया दिख रहा है वो EMB अगार मीडिया है। EMB अगार मीडिया में यदि हम स्ट्रिकिंग करते हैं ई कोलाई का तो उसमें हमको इस तरह से ग्रीन मेटेलिक सीन वाले कॉलोनीज दिखाई देते हैं। वो देखिए एकदम प्योर कल्चर है, उसमें और भी दूसरी तरह के कोई भी कॉलोनी डेवलप नहीं दिख रही है। इसके अलावा उसके साथ साथ में हम उसकी स्टेनिंग करते हैं। तो यदि वो ग्राम नेगेटिव है, जैसे ग्राम नेगेटिव की स्लाइड कैसे दिखेगी, पिंक कलर के दिखते हैं सेल्स, तो उस तरह के सेल्स हमको मिलते हैं। तो ये हमारा कंफर्म हो जाता है कि वहाँ पे कोलीफॉर्म्स उपस्थित हैं या एंटेरिक बैक्टीरिया का वहाँ पे प्रेजेंस है ना। इससे क्या सिद्ध होता है आपको किसी को पता है? मान लीजिए अगर उसमें आ गया कोलीफॉर्म टेस्ट हमारा पॉजिटिव आता है, उससे का क्या मतलब आप लोग निकालेंगे? मान लीजिए उसमें ई कोलाई का ग्रोथ आ गया, इससे क्या समझेंगे आप लोग? ई कोलाई की ग्रोथ यदि आ गई तो उससे आपको क्या समझ में आएगा? कंटामिनेटेड है। किस तरह का कंटामिनेशन है? ई कोलाई का कंटामिनेशन। ई कोलाई कहाँ रहता है वैसे? ठीक, मतलब हमारा वो कौन सा, कहाँ पे, ये ई कोलाई कमेंसल ऑर्गेनिज्म है और वो कहाँ रहता है? हमारे एलिमेंट्री कैनाल का बैक्टीरिया है, समझ रहे हो? एलिमेंट्री, इसीलिए ई कोलाई यहाँ पे इंडिकेटर ऑर्गेनिज्म है। जैसे कि हमने एक इंडिकेटर ऑर्गेनिज्म की बात की थी ना, इंडिकेटर ऑर्गेनिज्म है। इंडिकेटर का मतलब जो इंडिकेट करता हो, जो बताता हो, जो सूचना देता हो, वो सूचक है ना। तो ये ई कोलाई क्या है? इंडिकेटर है यहाँ पे। तो ये इंडिकेट करता है कि यहाँ पे फीकल कंटामिनेशन है, मतलब कहीं ना कहीं से यहाँ पे सीवेज वगैरह का जो है लीकेज हो रहा है या इस पानी में कंटामिनेशन है, वो उपयोग करने लायक नहीं है। क्योंकि अगर वो फीकल कंटामिनेशन है इसका मतलब क्या है कि वहाँ पे पैथोजेनिक ऑर्गेनिज्म होने की पूरी संभावनाएं हैं। ठीक है, तो इस तरह के अगर हमारा एमपीएन पॉजिटिव आता है रिजल्ट, उसमें इकोलाई की ग्रोथ आ जाती है या दूसरे कोलीफॉर्म्स की ग्रोथ आ जाती है, सिजेला की, साल्मोनेला की, तो हम उस पानी का उपयोग ना करें तो अच्छा है हमारे लिए, या उसको फिर से ट्रीटमेंट करें। नेक्स्ट करेंगे। इसके अलावा है आपका स्टैंडर्ड प्लेट काउंट, जिसके बारे में अपन पहले भी बात कर चुके हैं। स्टैंडर्ड प्लेट काउंट एक मेथड है जिसमें कि हम बैक्टीरियल लोड का पता करते हैं कि कितना बैक्टीरिया, कोई भी जो सैंपल है उसके 1 ml सैंपल में कितना बैक्टीरिया है। जिसमें दो तरह के मेथड्स हैं। एक होता है आपका स्प्रेड प्लेट टेक्निक, जिसके बारे में हम वी हैव ऑलरेडी डिस्कस्ड अबाउट द स्प्रेड प्लेट टेक्निक, जिसमें हम बहुत ही छोटा सा सैंपल लेकर के 0.1 ml लेकर के हम स्प्रेड करते हैं प्लेट के ऊपर और कॉलोनीज की काउंटिंग करते हैं कि कितनी कॉलोनी उसमें आई, है ना। उसके पहले यदि हम उसमें बहुत डेंस कॉलोनी मिलती है तो हम क्या करते हैं, अपने सैंपल को प्रॉपर डाइल्यूशन करते हैं, उसका सीरियल डाइल्यूशन करते हैं कि कितने फोल्ड हमने उसको डाइल्यूट किया, 10 फोल्ड डाइल्यूट किया कि 100 फोल्ड डाइल्यूट किया, है ना। उसके बाद डाइल्यूटेड सैंपल को हम स्प्रेड करते हैं जिससे कि हमको डिस्टिंक्ट कॉलोनी मिलती है। डिस्टिंक्ट कॉलोनी मिलने का मतलब यह है ताकि हम उसको काउंट कर पाए, क्योंकि अगर बहुत ज्यादा कॉलोनी घनी मिलेंगी तो हम उसको काउंट नहीं कर पाएंगे, वो काउंटेबल नहीं होंगी, तो हमारा रिजल्ट जो है वो प्रॉपर रिजल्ट नहीं कहलाएगा। तो अगर हम उसको सिंगल कॉलोनीज डेवलप होती है जिसको हम प्रॉपरली काउंट कर सकते हैं, तो उसके लिए हम उसको क्या करते हैं, उसका डाइल्यूशन बना लेते हैं, डाइल्यूटेड सैंपल का उपयोग करते हैं, जिससे कि हमको अलग अलग कॉलोनीज दिखती हैं और उसके हिसाब से उसको डाइल्यूशन फैक्टर के साथ में मल्टीप्लाई कर दिया जाता है। जैसे कि अगर मान लीजिए कि 0.1 ml में 10 बैक्टीरिया मिल रहे हैं तो 1 ml में कितने मिलेंगे? 100 मिलेंगे? मिलेंगे कि नहीं? समझ रहे हो ना ये बात? उसी तरह से डाइल्यूशन किया जाता है उसका, ताकि हमको प्रॉपर उसकी ग्रोथ मिल पाए। तो इस तरह से हम स्टैंडर्ड प्लेट काउंट्स का भी उपयोग करते हैं। नेक्स्ट करेंगे। ये तो ऑलरेडी हम लोग डिस्कस कर चुके हैं, तो इसको मैं आगे नहीं जाऊंगी। नेक्स्ट करेंगे। अब है आपके चैलेंजेस इन प्लैंक्टोनिक बैक्टीरियल स्टडीज। क्या क्या आपके चैलेंजेस आते हैं? एक तो है, पहला चैलेंज है आपका चेंजेस इन इन्वायरमेंटल वेरिएबिलिटी। इन्वायरमेंटल वेरिएबिलिटी मतलब हमारे, अगर हम ये काम करना चाहते हैं तो हमारे सामने कौन कौन सी ऐसी दुविधाएं उत्पन्न हो जाती हैं या कौन कौन सी चीजें हमारे सामने आ जाती हैं। तो बहुत बड़ा ये फैक्टर है इन्वायरमेंटल वेरिएबिलिटी। चेंजेस इन टेम्परेचर, पीएच एंड न्यूट्रिएंट। भाई लगातार टेम्परेचर चेंज हो रहे हैं या उसका पीएच चेंज हो रहा है या कोई भी इन्वायरमेंटल जो कंडीशंस अगर चेंज होंगे तो उसके अकॉर्डिंग हमारा रिजल्ट भी क्या हो जाता है, चेंज हो सकता है। फिर आज हमने इस कंडीशन में मान लीजिए बारिश के दिनों में किया तो कुछ अलग रिजल्ट आएगा, अगर गर्मी के दिनों में किया तो कुछ अलग रिजल्ट आएगा। मतलब अलग अलग मौसम के हिसाब से रिजल्ट भी बदल सकते हैं, अलग अलग जगह के हिसाब से भी रिजल्ट बदल सकते हैं। तो उसका एक स्टैंडर्ड जो वैल्यू है उसको फाइंड आउट करना थोड़ा सा दिक्कत करता है या मुश्किल होता है। इसीलिए हमको सीजनल सैम्पलिंग करना पड़ता है। मतलब हर एक सीजन में सैम्पलिंग करो, हर महीने में सैम्पलिंग करो, इस तरह से करके हम उसको रिजल्ट को एक रिलायबल रिजल्ट में कन्वर्ट कर सकते हैं। फिर उसके बाद है सैंपल कंटामिनेशन। ये बहुत बड़ा फैक्टर है कि हमने जो सैंपल लाया, आइसोलेशन भी कर लिया, लेकिन उसमें कंटामिनेशन होते हैं। क्योंकि जो बैक्टीरिया की जो, भाई वो इतना बड़ा थोड़ी है कि वो दिखेगा आपको, है ना, कि ये चीज है ये चीज है, इतना तो नहीं है, वो दिखेगा नहीं। उसकी एक जैसे कॉलोनी दिखती है सबकी, आपको बहुत कम डिफरेंस होता है, तो आपको पता भी नहीं चलेगा कि कब उसमें कंटामिनेशन हो गया। तो इसलिए हमको बीच बीच में उसको चेक करना पड़ता है कि कंटामिनेटेड तो नहीं है, उसको फिर से स्ट्रीकिंग करो, फिर से स्ट्रीकिंग करो, और उसके कॉलोनी कैरेक्टरिस्टिक्स को अपन ऑब्जर्व करते रहते हैं कि उसमें किसी प्रकार का कोई कंटामिनेशन ना हो। और ये बहुत बड़ा चैलेंज है लेबोरेटरीज के लिए कि कंटामिनेशन को कैसे हम कंट्रोल करें। उसके लिए प्रॉपर आपको एसेप्टिक कंडीशन डेवलप करना आवश्यक होता है। उसके अलावा है लो अबंडेंस। कुछ जो ऑर्गेनिजम्स हैं उनकी संख्या बहुत कम होती है, बहुत रेयर ऑर्गेनिजम्स होते हैं, और उनको आइसोलेट करना एक बहुत टीडियस जॉब होता है कि हमारा जो सैंपल साइज है क्या उस सैंपल में वो आया है कि नहीं आया है। तो ये भी एक बड़ा एक मुद्दा है। नेक्स्ट। अब इसके कहाँ कहाँ एप्लीकेशंस हैं या इस टेक्निक को हम कहाँ कहाँ अप्लाई करते हैं। तो सबसे पहला है आपका वाटर क्वालिटी असेसमेंट, जिसके बारे में इतनी देर से बात हो रही है कि वाटर की जो क्वालिटी है उसको हम असेस करने के लिए कि किस तरह का हमारा पानी है, वो पीने लायक है कि नहीं है। मॉनिटरिंग ड्रिंकिंग वाटर एंड रिक्रिएशनल वाटर। ड्रिंकिंग वाटर के साथ साथ में हमको रिक्रिएशनल वाटर की भी मॉनिटरिंग करना चाहिए। रिक्रिएशनल वाटर मतलब जैसे स्विमिंग पूल है, पॉन्ड्स हैं, लेक्स हैं, रिवर्स हैं, दे आर द रिक्रिएशनल वाटर, जहाँ पे जाके हम दूसरी एक्टिविटीज, अदर बाथिंग वाशिंग और डिफरेंट टाइप की जो एक्टिविटीज जो करते हैं, तो वो वाटर भी अगर वहां भी कंटामिनेशन हो तो भी हमारे बॉडी में अंततः आ जाएगी और उससे हमको डिजीज होने के बहुत सारे चांसेस हो सकते हैं। पब्लिक हेल्थ आइडेंटिफाइंग पैथोजेंस इन कंटामिनेटेड वाटर। जो कंटामिनेटेड हमको पता भी चल गया कि हाँ ये पानी कंटामिनेटेड है, तो उसको हम आइडेंटिफाई करने के लिए भी हम इसी प्रोसेस का उपयोग करते हैं कि क्या जो वाटर है उसमें साल्मोनेला का कंटामिनेशन है, कि क्या उसमें किसका कंटामिनेशन, कौन सा पैथोजन है, उसको आइडेंटिफाई करने के लिए भी हम इन प्रोसेस का इस्तेमाल करते हैं। देन है आपका इकोलॉजिकल रिसर्च के लिए स्टडिंग माइक्रोबियल रोल्स इन एक्वेटिक इकोसिस्टम, जो कि जनरली आप लोग सभी जानते ही हैं कि माइक्रो ऑर्गेनिजम्स का जो रोल है वो इकोलॉजिकल बैलेंस के लिए कितना आवश्यक है। तो वो बैलेंस किस तरह से इकोलॉजी को ये अफेक्ट करते हैं, ये इकोसिस्टम को हमारे कैसे ये रेगुलेट करते हैं, एक्चुअली दे रेगुलेट द इकोसिस्टम्स। तो ये इसकी जो मॉनिटरिंग करना या इसको जो स्टडी करने के लिए भी इसी तरह के टेक्निक्स का हम इस्तेमाल करते हैं। थैंक यू। अगर किसी को कोई डाउट हो तो। अरे देखिए सर, कोई भी अगर सर देखिए कोई भी अगर पैथोजेनिक ऑर्गेनिज्म है उसमें तो वो कंटामिनेशन से ही आएगा। वो कभी वाटर बॉडी में इटसेल्फ, वाटर बॉडी के अंदर का कंटामिनेशन नहीं होगा, अंदर से नहीं आएगा। तो पैथोजेनिक फॉर्म से या तो कहीं से कंटामिनेशन है, सीवेज का कंटामिनेशन, क्योंकि यहाँ पे हम कोलीफॉर्म की स्टडी करते हैं या दूसरे पैथोजन की भी हम स्टडी, इवन वायरस की भी स्टडी हम कर सकते हैं। तो वो कहीं से कहीं ना कहीं तो उसका है जहाँ से वह वहां पे पहुंचा है उस वाटर बॉडी में। अब उस सोर्स को हमको ढूंढना पड़ेगा कि कौन सा सोर्स है जो एक्चुअली वाटर बॉडी को कंटामिनेट कर रहा है। क्या उसमें कोई वेस्ट का ड्रेनेज हो रहा है, क्या उसमें सीवेज को बिना किसी ट्रीटमेंट के डाला जा रहा है। तो इस तरह से अपन उसको पैथोजेंस को हम देख सकते हैं। जैसे हॉस्पिटल वेस्ट वगैरह को अगर डायरेक्टली रिवर में कर दिया जाए तो उसमें बहुत सारे पैथोजेंस जो है आ सकते हैं। तो उस पॉइंट को या उस रिजर्वायर्स को हमको देखना होगा। और किसी को कुछ पूछना है क्या? हाँ, देखिए क्या होता है कि स्पेक्ट्रोफोटोमेट्रिक इसलिए मैंने बताया, एक्चुअली उसको आगे मैंने थोड़ा सा इलेबोरेट नहीं किया। एक्चुअली जो ग्रोथ का जो मेजरमेंट है कि ग्रोथ इसमें दो तीन चीजों का देखा जाता है। जैसे कि कार्बन सोर्स, अलग अलग कार्बन सोर्स में ऑर्गेनिज्म की ग्रोथ कैसी होती है, अलग अलग साल्ट कंसंट्रेशन में ऑर्गेनिज्म की ग्रोथ कैसी होती है। तो उस ग्रोथ को हम मेजर करते हैं। जब डिफरेंट साल्ट कंसंट्रेशन है तो उसमें साल्ट स्ट्रेस कितना वो सह सकता है ना। तो उससे हमको पता चल जाता है कि वो किस तरह का ऑर्गेनिज्म है करके, कि 1% साल में ग्रो करता है, 10% में ग्रो करता है, या 1% में भी ग्रो नहीं करता है, या कि 5% में ग्रो करता है। इस तरह से हम ग्रोथ को मेजरमेंट करने के लिए स्पेक्ट्रोफोटोमीटर का उपयोग करते हैं। इसके अलावा डिफरेंट जो पीएच है उसमें क्या ग्रोथ पैटर्न है उसका, उसके लिए भी हम स्पेक्ट्रोफोटोमेट्रिक जो मेथड है उनका उपयोग करते हैं। हाँ, हम्म, हम्म, हम्म। CFU मैम, CFU इज द कॉलोनी फार्मिंग यूनिट। कॉलोनी फार्मिंग यूनिट जो है उसको अपन कहेंगे कि जो वायबल काउंट है। वायबल देखिए ऑर्गेनिज्म जो है वो दो तरह के हैं वहाँ पे, वायबल भी हैं और नॉन वायबल। वायबल मतलब जो कि ग्रो करते हैं, और बहुत सारे ऐसे हैं जो कि ग्रो नहीं करेंगे, हैं वहाँ पे पर ग्रो नहीं करेंगे। तो कॉलोनी कौन फार्म करेंगे? जो वायबल होंगे केवल वो कॉलोनी फार्म करेंगे। तो दे आर कॉल्ड द वायबल नंबर, या उसको कहते हैं हम कॉलोनी फार्मिंग यूनिट। कॉलोनी फार्मिंग यूनिट का मतलब होता है एक्चुअली जितने सेल्स होते हैं, हम लोग ये मान के चलते हैं कि जितने सेल्स हैं वो सेल्स अलग अलग कॉलोनी फार्म कर रहे हैं। तो जितनी कॉलोनी मिलेगी तो वो उतने ही उसमें सेल्स हैं, मतलब वो है कॉलोनी फार्मिंग यूनिट। और जैसे आप बोल रहे हैं कि डायलूशन फैक्टर का इसमें हम इस्तेमाल करते हैं। जैसे कि मान लीजिए अगर हमारा सैंपल है वो काफी ज्यादा कंटामिनेटेड है तो हम उसको डाइल्यूट करेंगे, क्योंकि नंबर ऑफ सेल्स अगर बहुत ज्यादा है तो वो काउंट नहीं किया जा सकता कॉलोनी के रूप में। तो हम उसको क्या करेंगे, जैसे पहले 10 फोल्ड डाइल्यूट कर दिए तो 10⁻⁻1 मतलब 9 ml डिस्टिल वाटर और 1 ml हमने सैंपल लिया, तो 10 गुना वो डाइल्यूट हो गया। अब उसको होमोजेनाइज किया, उसके बाद आगे हम उसको फिर से सीरियली डाइल्यूट किया, फिर से हम उसको अगेन 10 गुना डाइल्यूट कर रहे हैं। तो इस तरह से डाइल्यूशन फैक्टर कितना हो गया, जैसे मान लीजिए हमने 3 बार डाइल्यूट किया उसको आगे, तो डाइल्यूशन फैक्टर हो गया 10⁻3। मतलब 1000 में अगर हमको 2 कॉलोनी मिल रही तो इसका मतलब हम ये कहेंगे कि 2 कॉलोनी फार्मिंग यूनिट है ना। और कितने में है वो? 1000 डाइल्यूशन है उसका, तो डाइल्यूशन फैक्टर उसका हो जाएगा 10⁻3। मतलब वहां पे कितना हो रहा है? 2000 कॉलोनी उसको माना जाएगा 1 ml। ये है कॉलोनी फार्मिंग यूनिट। तो लोड ज्यादा है, लोड ज्यादा है वहां पे। CFU कम है तो लोड कम है। हाँ सर बोलिए। जी हाँ, हाँ, हाँ सर। सर इसमें एक तो ये एक्चुअली ये जो टेस्ट है वो मॉनिटरिंग के लिए है, कि जो हम लोग मॉनिटरिंग करते हैं वाटर बॉडी का, कि एक्चुअली उसमें क्या कंटामिनेशन आ रहा है कि नहीं आ रहा है, या कंटामिनेशन का सोर्स क्या है। तो कंटामिनेशन अगर हमको ये पता चल गया कि कंटामिनेटेड है तो उसका जो ट्रीटमेंट प्रोसेस है सर, उसका जो डिसइंफेक्शन जो प्रोसेस है उसको हमको थोड़ा सा उसकी मॉनिटरिंग करनी पड़ेगी कि इसका डिसइंफेक्शन जो प्रोसेस है वो प्रॉपर हो रहा है कि नहीं। क्योंकि आपका जो ट्रीटमेंट मेथड है वाटर बॉडी का, प्राइमरी सेकेंडरी और जो टर्सरी टेस्ट है, तो टर्सरी टेस्ट को हमको आइडेंटिफाई करना होगा कि टर्सरी टेस्ट में हम ऐसा कौन कौन सा और मेजर्स लें, लाइक द ओजोनेशन हम उसका करें या क्लोरिनेशन करें, या किस तरह से उसको हम कर सकते हैं जिससे कि ये जो है कंटामिनेशन होने से उसको हम रोक पाए, या हमारे पास जो पानी पीने के लिए आ रहा है कम से कम उसमें पैथोजेंस ना हो। इसके अलावा अगर वो आ ही गए हैं, मतलब हम भाई म्युनिसिपल कॉर्पोरेशन पे हम इतना दबाव तो नहीं बना पाएंगे या नहीं शायद कह पाएंगे, तो हम लोग सर जैसे उसको वही प्रोसेस जो बाकी जो हमारे RO का वाटर और फिल्टर करके, और इसके अलावा आपका बॉइलिंग जो है वेरी गुड प्रोसेस, तो इस तरह से करके हम उसमें बच सकते हैं या प्रिवेंट कर हमारा जो डिजीज से अपने आप को हम बचा पाते हैं। यस, हाँ हाँ काउंट है। हाँ, नहीं करते। हाँ, नॉन वायबल जो सेल्स हैं ये कभी कॉलोनी फॉर्म नहीं करेंगी। नॉन वायबल सेल्स जो है कॉलोनी फॉर्म नहीं करती हैं, इसीलिए मैंने यहाँ से पोर प्लेट टेक्निक रखा नहीं। एक्चुअली क्या है, पोर प्लेट टेक्निक सबसे शुरुआती वाला टेक्निक है, और पोर प्लेट टेक्निक का ये बहुत बड़ा लिमिटेशन है कि सरफेस की कॉलोनी को तो हम काउंट कर पाते हैं, लेकिन कॉलोनी अपीयर्स में सब सरफेस एरिया हम उसको काउंट करने का हमारे पास कोई टेक्निक नहीं है, या उसको हम काउंट नहीं कर पाते हैं। इसके अलावा जो एजेस में जो कॉलोनी डेवलप होते हैं उसको भी हम काउंट नहीं कर पाते हैं। इसलिए जो पोर प्लेट मेथड से ज्यादा जो बेटर मेथड है वो स्प्लिट प्लेट मेथड है और आपका स्ट्रिक प्लेट मेथड है। नहीं नहीं, नॉन वायबल कॉलोनी नहीं है वो कॉलोनी जो भी फार्म करेगा वो वायबल सेल ही कॉलोनी का फार्म करेगा। वो इसका लिमिटेशन है पोर प्लेट टेक्निक का कि हम सब सरफेस की कॉलोनीज को नहीं काउंट कर पाते हैं, क्योंकि भाई हम क्या कर देते हैं पोर प्लेट में पूरा हम मिक्स कर देते हैं सैंपल को मीडियम के साथ में, और उसको हम पोर करते हैं। तो उसमें क्या होगा, दोनों भाई नीचे भी तो कुछ बैक्टीरिया रहे होंगे, ऊपर ऊपर रहेंगे, ऊपर में कॉलोनी फॉर्म कर लेंगे, लेकिन जो नीचे है, जो नीचे तलहटी में जो जमे हुए हैं वो उसकी कॉलोनी बनती है पर वो हमको दिखती नहीं है। एक्चुअली वहां वो ग्रो जरूर कर रहे हैं पर वो हमको दिखती नहीं है, उसको हम काउंट नहीं कर पाते हैं प्रॉपरली। ओके, थैंक यू सो मच फॉर द
I extend my heartfelt thanks to Dr. Sadhna Jaiswal madam for giving such a wonderful lecture and clearing all the doubts of students. Thank you so much, ma'am. So you may please join the microbiology lab for the practical session. All the students should go there.
Thank you, ma'am.
Recording stopped.